Welcome back, guys. So this is section 4.1 of chapter number 4, in which we are going to discuss the Boolean operations and expressions. Okay, so the question 1 here is that using Boolean notation, write an expression that is 0 when only all of its variables a, b, c and d are zeros. Okay, so we have to find out that when all the variables of the expression are zeros, then the output of it will be zeros. So this expression is, let me write here the one. So which type of expression is that? Let me write it denote it with x, and that expression, as we can recall it, that is the OR expression or this addition operator. Okay, so writing it with this one, what we can do, x is equal to the a plus b plus c plus d. Okay, so writing here 0 1 0 0, we can see that only this b of it is 1, so it will give me 1. Okay, so if any of them is 1, the output of it will be x equal 1. So therefore all of them should be equal to what? All of those should be equal to 0 to give me the output equal to 0. So that is the answer of my question 1. Okay, similarly for question number 2 here, what is it asking me? That write an expression that is 1 when one or more of its variables are 0. Okay, so here in previous question we have seen that if any of them is 1, so output will be 1. Okay, so here it is asking that if the literals which we have are, so those are a, b, c, d and e. So if any of them is what? Any of them is 0, the output will be what? The output should be 1. Okay, so what it can be? So writing it with or denoting it with this y, so we can see that if that is a plus b plus c plus d plus e, so here making any of them 1 will give me the output equal to 1. Okay, so suppose if I want to make the inverse of it, that if any of them is 0, the output will be 1, so making it the complement will serve it. Okay, so the answer of it, the question number 2 is this. So let me check it first. So let me have here a equal to 0, this is equal to 1, and this is 1, this is 1, and this is 1, and the complements of them here, let me write their complements, and I can see that all of them will be zeros while this one will become 1. So the output of it will be 1 plus 0 plus 0 plus 0 plus 0. So it will ultimately give me what? This will ultimately give me 1. Okay, so that is the answer of my question, that the answer of it is a plus b plus c plus d plus e whole complement. So that is the answer of part 2 here. Okay, let me now start question number 3. So write an expression that is 0 when one or more of its variables a, b, c, d are zeros. Okay, so that is the question number 3, and here we have the literals a, b, c. Okay, so I want to represent it with this z, and I want to make the expression out of them that if any one of them is 0, it will give me 0. So it is clearly the AND operation. Okay, so in AND, if any one of them is 0, it will give me the 0, and it will only be 1 if all of them are 1. Okay, so that would be a, b, c. So that is the answer of part 3 here. So that is the answer of my question here. Question number 4 is we have to evaluate the following expression. So that is the question number 4. So in part A of it, we have 0 plus 0 plus 0 plus 0. So as all of them are 0, so this would be 0. Okay, in part B, we have 0 plus 0 plus 0 plus 1, and that is equal to 1 because any of them is 1, and that is the OR operation. And according to the Boolean operations or Boolean arithmetic, what we have, if any of the items in the OR operation is 1, that would be 1. Okay, so in part C here as well, we have all 4 equal to 1. Okay, so this is like 4 switches, and if all of those are connected in parallel and all are basically short circuited, the output will also be short circuited, and that is 1 as well. Part D here is 1.1 plus 0.0 and plus 1. Okay, so in order to evaluate them, what we have to do, first of all, we have to perform this dot operation. So 1.1, as both of them are ones, so that is the AND operation basically. So here we have 1. Okay, similarly here we have 0.0, so both of them are open, or both of them are 0, so I will have here 0 as well, and that is 1. And ultimately from them we can see that here we have these plus operators here, so we can see that adding them together, ultimately I will get here what? The answer of it will be 1. Okay, so that is the answer of part D. Okay, writing the part E here, we have 1.0.0 sorry, that is what? That is not 0, and that is 1.0. Okay, so this is the dot operation, and according to the Boolean operators, if in dot operation any one of the operators is 0, what we will get? We will get 0. Okay, so this is here we have 2 zeros, so therefore the answer of it will be 0. Okay, in part F we have 1.0 plus 1.0 plus 0.1 plus 0.1. Okay, now evaluating them, and these are all the dot operators here. So this is a dot, this is dot, this is dot, and this is dot. Let me first evaluate them, and we will see that here we will get 0, this is 0, this is 0, and this is 0 as well, because in dot operations, is if any of the operator is 0, we will get 0. Okay, so after dot operator we have to perform this plus operation here, which is basically the OR operation. So this plus is the OR operation, while this dot is the AND operation. Okay, so now we can see that all of the operators here are 0, so here we have the answer as 0. So that is the answer of question number 4, and we have seen that how easy it is to evaluate different operators which are in the form of the Boolean operators. So thank you so much, and I will see you with some more questions in our upcoming video. See you soon. Welcome back, guys. So this is question number 5, and we have to find the values of the variable that make each product term 1 and each sum term equal to 0. Okay, so what we have to do, if we have 3 operators A, B and C, so what we have to do, we have to make their sum of them equal to 0. Okay, and their product equal to 1. Okay, so that is the scenario here. So in order to do it, let me start writing the first question, and that is ABC. So we can see that we have to write the values of A, B and C, which will make them equal to what? Equal to 1. So that is the product. So now let me first draw a line here. So let me draw a line here. So now using this white color for it, and here the question number A is ABC, and that is basically the multiplication. Okay, so for multiplication, we can see here that for multiplication we have to make it in such a way that it should give me 1. So what should be the value of A? Is here the value of A should be 1, the value of B should be 1, and C here as well 1. Okay, so here it will give me what? It will give me 1 1 1, and the expression here will also remain ABC. Similarly, in part B here we have A plus B plus C. Okay, so I want to make it 0. So if 0 0 0, if 3 of them is zeros, the output of it will give me what? The output of it will be 0 here as well. So again, let me draw the lines here as well. So part C here is that is part C, and part C is A prime, B prime and C, and in order to make it make this expression equal to what, this expression should give me 1 because all the operations here are the multiplication, so it should be 0 0 1 here. Okay, similarly for D here we have D A prime plus B prime plus C. So what should be here, so in order to make it 0, what I should have here, A should be 1, B should be 1, okay, and C should be what, C should be 0 as well. So here this one is what, this is the question number D. Now let me move down further and now solving this question E here. So E is what, A plus B prime plus C prime, and that is the plus operation or the summation operation. What we have to do, we have to make it equal to 0. So this A should be 0, this should be 1, and this should be 1. And for the last part here, that is part F, and part F we have A prime plus B prime plus C prime. Okay, so in order to make it what, this is the plus operation here as well, and for plus operation we have to make them all equal to 0. So therefore I have to give all of them equal to 1 1. Okay, so the expressions here will remain the same as that of it, this and this as well. Basically this column is not required here, but I have used this column for the convenience that the input and output expressions will remain the same, but only the values of the operators will change here. Okay, so that is the answer of my question, in which we have solved the question number 5, and we have seen that what are the values of the operators which should give me the required results for the addition and the multiplication. So thank you so much, and I will see you with some more questions in our upcoming. Welcome back guys. So this is the question number 6, and we have to find the values of x for all the possible values of the variables. Okay, so what are the variables which we have been using here? These are the A, B and C. Okay, so we have the variables A, B and C, and what could be their possible values? The possible values we could have here are the, let me use this white color for it. So those can be 0 0 0, 0 0 1, 0 1 0, okay, and 0 1 1. Similarly 1 0 0, 1 0 1, 1 1 0, okay, and 1 1 1. Okay, so here what we have to do, we have to check all the possible values of x for these values which are given to these operators. Okay, so let me use this red color here for the lines. This is for it. Okay, so question A is A plus B plus C. So that is A plus B plus C. Okay, so to find the output of it for different values of A, B and C, what we will have, so that is the OR operator. So if any of the inputs or any of the values here is what, that is 1, the output will be 1. So for it is 0, so for it is 1 1 1 1 1 1 1. So this is a quite easy one, the line here for my question 1. Similarly the question 2 here is that A plus B multiplied by what, multiplied by C. Okay, so here as all of them are zeros, so here the output will be 0 as well. So, okay, so that would be 0. Similarly here we have A is 0, so putting the value for it, A equal to 0 and B equal to 0, so 0 plus 0 is 0, so 0 multiplied by this 1, that would be 0 as well. Okay, similarly here for this combination, here we have 0 1 0, so 0 1 0, putting A 0, B 1, so I will get 1, and 1, this C is 0, so again I will get 0. Okay, similarly here 0 plus 1 is 1, and 1 multiplied by 1 is 1. Okay, this one is 1 plus 0 is 1. 1 multiplied by 0 is what? That would be 0 here as well. Similarly, 1 plus 0 is 1 and 1 multiplied by 1 is 1 here as well. 1 plus 1 is 1 and 1 multiplied by 0 is 0, and here 1 plus 1 is 1. 1 multiplied by 1 is, that is 1 here. Okay, so that is the solution of part B here. Now let me try this, sorry, part C here, and part C is a plus b, okay, and b plus c whole prime. Okay, and let me draw this red line for separating out. So now here a plus b, use this white color, so a plus b is 0 plus 0, so that would be 0, and b plus c is 0, so 0 multiplied by 0 is, here the output will also be 0. Similarly, 0 plus 0 is 0, and that would be 0 plus 0 is 0, and b plus c is 0 plus 1 is 1, so 1 prime is again 0, so we will get what? 0 multiplied by 0 is what? We will again have this 0. Okay, similarly for part C here, 0 plus 1 is 1, okay, and b plus c is 1 plus 0 is 1, and 1 prime is what? That is 0, so we will have here 0. Similarly, a plus b is 1, okay, and 1 plus 1 is 1, and prime of it is what? That is 0, so here we will have 0. Here 1 plus 0 is 1, okay, 0 plus 0 is what? That is 0, and prime of it is 1, so here we will have what? 1. 1 plus 0 is what? 1 plus 0 is 1, and 0 plus 1 is 1, and the complement of it will be 0, so here we will have 0. So 1 plus 1 is what? That is 1, and 0 plus 1 is what? That is also 1, and the complement of it is 0, so I will again have 0. 1 plus 1 is 1, okay, again, and 1 plus 0 is 1, and complement of it is 0, so I will get here 0 as well. 1 plus 1 is 1, and 1 plus 1 is also 1, and the complement of it is 0, so I will get here 0 as well. So that is the answer of my question C. For question D here, we again have to put the values and see that what could be the answer here. So I am leaving it for your own practice, part D and part E, and we will try to solve it in our upcoming video, because this is now enough for this video, and I will see you that how to solve these in upcoming video. Thank you so much, and I will see you soon. So welcome back, guys. This is question number 6, and previously we have solved part A, B and C of this question, while D and E were left. So today we are going to talk about the part D and E. So let me first remove all the things here. So here we have x, and x is equal to a plus b, okay, and plus ab plus bc whole complement. Okay, so what we have to do, we have to use these parts here to find the output, but here in these columns we have to split these parts, and first we have to solve this a plus b here. We have to find this a plus b here, and then here ab plus bc here. Okay, so once we will write them at the end, we will have to write them here, and it will give me the output. Okay, so that is ab plus bc whole complement. So writing them here, a plus b is here 0, okay, or let me use white color here as well. So this is a plus b, so a plus b is 0 here. Here it is ab is 0, and bc is how much? AB is A is 0 0 and BC is 0 0 0 plus 0 is 0, so the complement of it is 1. Okay, similarly here A plus B is 0 and AB is 0, BC is also 0, okay, because 0 1 is 0, and 0 plus 0 is 0 and the complement of it is again 1. Okay, 0 plus 1 is 1 here. Here 0 multiplied by 1 is 0 and BC 0 1 multiplied by 0 is 0, so 0 plus 0 is 0 and complement of it is 1 here as well. Here what it will be, 0 plus 1 is 1. Okay, AB is A multiplied by B is 0 and plus B multiplied by C is 1 1 1, so 0 plus 1 is 1 complement of 1 is here 0. Okay, similarly here A plus B is 1 because here A is 1, B is 0, so A plus 0 is 1. AB, here we have to solve. AB is 0 and BC is also 0, so 0 plus 0 is 0 and the complement of it is 1, so here we will get 1. Here 1 plus 0 is 1. What it will be here, 1 multiplied by 0 is 0, 0 multiplied by 1 will be 0 as well, so 0 plus 0 is 0 and complement of it is 1 here as well. A plus B is 1. Okay, A B is what here, A is 1, B is 1, so it will be 1 and B plus C is 0, so 1 plus 0 is 1 and complement of it will be 0 here. And here what we have to do here, it will be 1, AB is 1, BC is 1, 1 plus 1 is 1 and the complement of it will be 0 here. Okay, so from it we can very easily find the output of it, and that will be the addition of A plus B, which is here, and AB plus BC whole prime, which is here. So we have to add them together, and here we will get 0 plus 1 is 1 1 1 1 1 1 1 and 1, so all of them will be 1, and that is what, that is the answer of my question, which is D here. Okay, so that is the answer of my question, and we have solved them by using or by converting it into different parts. So first we have calculated or solved the part 1 and then part B of it, the second half of it, and then adding them together I will get the output. Okay, so now let me solve part E of my question, and for part E let me remove it as well. So here removing it, color, so here the part here is AX is equal to A prime plus B prime and its multiplication with A plus B. Okay, so that would be the dot product, and here we have to find out A prime plus B prime. Okay, and here we have to find out A plus B, and at the end what we have to do, we have to multiply them. So all the procedure will remain the same as we have previously done, so using this white color for it. So here in this question we will have to restrict ourselves into AB as compared to this C. Okay, so what we have to do, let me now remove this C from here as well. Okay, so how many combinations will I have? Removing it. Okay, removing it from here as well, removing it, and then this one as well. Okay, so we can see that now we have 4 combinations of the input while the C is not available here. So 0 0 will give me this combination, then 0 1, so A prime is now 1, B prime is 0, so 1 plus 0 is 1, and here 0 plus 1 is also 1. Okay, because here A is 0, B is 1, so 0 plus 1 is 1. Similarly here A prime, A is now 1, so A prime is 0, B is 0, so B prime is 1, so here I will get 1 here as well, while for this A is 1, B is 0, so 1 plus 0 is also 1. Okay, here we can see that A is 1 and B is 1, their complement is 0 plus 0, so here I will get 0, and here we can see that both of them is 1, so I will get here 1 as well. So here adding them together, here the combination is just like we have found out this part this part as well. So now multiply them, I will get 1.0 is 0. Okay, 1.1 is 1, 1.1 is 1, and 0.1 is what? That is also 0. So that is the answer of part E here, and we can see that we have solved all the problems, and for the last two of our problems we have first splitted them into the subparts, and at the end we have combined them to get the overall solution. So that is the end of our question, and I will see you with some more problems in our upcoming video. Till then, take care of yourself. Welcome back, guys. So this is section 4.4, and from here we will start the Boolean analysis of the logic circuits. Okay, so we have different logic circuits which we have covered in our theory section. Here to what we have to do, this is question number 12, and we have to write the Boolean expression for each of the logic gates in figure 4.56. so this is 4.56, and in part A, B, C, D we have different circuits which are known from the theory, that which of them is which of the circuits. So using the A here we have the two inputs A, B, while this circuit, this is called AND. Okay, so what we have to do, we have to write the expression for X. So let me use this X for it. So X is equal to A multiplied by B, because that is the AND gate, okay, which is clearly shown by the gate which is here, just like it. Okay, so that is what, that is A, that is B, that is X. So that is the AND circuit. Similarly, for part B here we have this circuit. Okay, so for part B we can see that we have one input, one output, and here we have this bubble. So therefore X is the complement of A, and that is basically the NOT gate. Okay, and this bubble basically shows us the complement operation which has been performed here, and that is the essence of this NOT gate or inverter. Part C here is, what is this? This is basically another type of circuit, and we have seen in our theory section that this is called OR gate. So what is the OR gate? The procedure or the mathematical operation performed here is just like the inputs are added together, and that is due to this OR operation, which is due to this OR gate. Okay, so we have previously seen that its symbol is just like this, where this is the output and here we have the inputs A and B. Okay, similarly part D here is, we have three inputs here, we can see that, and the same circuit here we have this one and this one. These two are basically the two same circuits. So therefore what we have to do, we have to write here that the output is the sum of A plus B plus C, and that is also the OR gate. Okay, so that is the solution of our question, and we have solved it. We have seen that what are different gates and what are their uses for different inputs. Okay, so in our upcoming section we will also try to solve more about them. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question number 13, in which again we have to write the Boolean expression for each of the following logic circuits which are shown here in figure 4.57. okay, so what are these combinations? So let me start it from part A here. So in part A we can see that all of these inputs are given to this AND gate, and therefore the output here we have is how much? That is X equal to A, B, C and D, because these are given to this AND gate and these are multiplied together due to the AND operation here. For part B here we can see that this is a circuit. So let me write part B here. So in order to solve it, what we have to do, just as we have used the divide and conquer rule in our previous section, the same we have to follow here. So let me use this red color for it, for this circuit. So initially we can see that we have three inputs which are A, B and C. Okay, so A, B and C. A and B is given to this AND gate. So which operation has been performed here? So the output of it will be here as A multiplied by B. Okay, so A, B will be multiplied together, and then this A, B and this C will be given to this OR gate, and we will see that this A, B and C will be added together, and here we will get A, B plus C. Okay, so that would be the output here. So therefore the answer of my question here will be A, B plus C due to the operations which are performed by these circuits. Okay, similarly in part C here, okay, we can see that here we have again two inputs, but here different gates are involved. Initially this A is given to this inverter, and then A and B are then given to this AND gate. Okay, so what we have to do, again we have to use the same procedure. When this A is given to this inverter, what will we get? We will get the complement of it. Okay, after getting the complement of it, A prime and B, these two are given to this AND circuit, and therefore the output here will be A prime and B, these two will be multiplied together. Okay, and once these are multiplied together, the output obtained from here will be given to this inverter here. So therefore what will we get? So A prime B whole complement here will be the output here. Okay, so that was the x, that is the value of this x, and we can write it here like x is equal to the A prime B and with the whole prime. So that is the output of this x. So we can see that that is very easy to find out the values if we divide them and obtain the outputs of each gates individually. Okay, and at the end we have to combine the output. Similarly, the part D here is, that is part D. And what is part D? We can again see that we have three inputs, what are A, B and C. So the first gate here we have is this OR gate. So to this OR gate, A and B are applied, so A and B will be added together or OR together. Okay, then this input and this C will be applied to this AND gate, and we can see that the output from here and here will be multiplied together. So therefore we will get A plus B multiplied by C. Okay, so that would be the output of my combination here, which is shown here. So therefore what will be the value of x? So the value of x will be A plus B whole multiplied with this C. Okay, so that is the solution of problem 13, and we have seen that how easy it is to find the outputs of different logic combinations or the logic gates which are combined together by using the Boolean operations. Okay, what are the next step and how to solve these type of expression to design any logical circuit will be the next topic, and we will talk about it in our upcoming video. Till then, take care of yourself and I will see you soon. Hello guys, so this is question number 14, and today we have to draw the logic circuits represented by each of the following expressions. Okay, so here we are given some expressions, and with respect to these expressions we have to draw the logic diagram. Okay, so the first expression we have here is A plus B plus C plus D. Okay, so what is basically the procedure here? So we can see that here we have four variables are involved. So let me draw them with this yellow color. So we have four inputs which are A, B, C, D, and there is an operation which has been performed in between them, and that is this plus operation. And in logic circuits we call this plus operation as the OR operation. Okay, so here we have, let me first write these inputs which are A, B, C and D. Okay, and these are basically added together with each other. So therefore for this operation we usually use an OR gate, okay, which is like this one. Okay, so that is A, B, C and D, and each one of them is given to it as an input. Okay, you can see that these are the inputs which are given to my circuit, and this basically give me the output which is here. Okay, so let me call it y. So that is the circuit implementation or the logic circuit representation of this expression, which is expression A. Okay, similarly we have part B here, and here we are given that we have A, B, C and D. Okay, and the operation which has been performed among them is basically the AND operation. Okay, so we can write here this AND. Okay, so again we can see here that we have 4 inputs, so let me write them with this red color. So we have A, B, C and D. Okay, and the input which has been given from them is this one. Okay, so these are basically given to a circuit or a logic circuit which is called the AND gate, and these 4 are given to this one. Okay, so this one and this one as well. Okay, so what is this? This is the output, and let me call it capital Y as well. Okay, so that is the answer of part B here, as we have done here. So these gates are basically the gates which can also have the 4 inputs. If for example we don't have the condition in which we are given the logic circuits where we don't have the 4 inputs, then the circuits for those circuits will be different as we have drawn here. Okay, so this is for the 4 inputs logic circuit. Similarly for part C here we have A plus B, C. So here we can see that how many inputs are involved here. Here we can see that we have A, B and C, 3 inputs. So in order to perform them, what we have to do, so initially in every circuit you can see that we have this input which is A. Okay, this has been added with the product of B and C. Okay, so what we have to do initially, we have to perform this BC operation, and after it this will be added with this A. So here this will be what, this is the first operation. We have to see that this is like the multiplication, and multiplication is always performed before the addition. So after it the product will be added with it. Okay, so let me first remove it. And now using this red color for the inputs, so here we have A, B, C are the inputs. Okay, and the signals from them or the inputs from them are here represented by them. First of all, B and C are multiplied together, and when these will be multiplied together, these will be given to the AND gate, which is represented by the signals, and it will give me what, this will give me what, this will give me BC. Okay, so after BC we have to add this BC with A. So now here writing this OR circuit, what it will do, it will add them together, it will add this A and BC. So now this will be the input signal to it, and it will be here as well. So it will be A, and A plus BC will give me the output, which will be here. So it is now A plus BC, which is the output. So what is this? This is basically the logic gate representation of the expression, which is A plus BC. Okay, so that is the circuit for it. So, and the last part here we have, let me write here the last part, and that is A, B, C plus D. Okay, so here we can very easily see that first of all we have to perform this operation, which is the AND operation among A, B, C, and at the end we have to add them with this D. Okay, so here what we have to do, let me draw them here as well. So here again we have A, B, C and D. Okay, we have 4 inputs, and let me draw their inputs 1, 2, 3, 4. These are the signals which will flow from these inputs. Okay, so first of all we have to multiply A, B, C, D. So there we will have the AND gate. Okay, and to this AND gate we have A, B, C. This will be multiplied together, and at the output of it we will get A, B, C. Okay, so that is the output of this first AND circuit. And after it, what we have to do here, we should have, okay, so let me use this. So here we will have this OR circuit, and to this OR circuit, this A, B, C and this D will be given, and here we will get A, B, C plus D, which will be the output as corresponding to this statement. Okay, so that is the solution of question number 14, and we have seen that by solving different parts here, we can very easily represent them by using the logic circuits which are given here. Okay, so that's it for today, and with some more questions I will see you in our upcoming video. Till then, take care of yourself. Welcome back, guys. So this is question number 15, and here we again have to draw the logic circuits represented by each expression. Okay, so the first expression we have here is AB plus AB whole prime. Okay, so that is the first question here we have. So we can very easily see that here only two variables are involved, and those are the A and B. So this is A, this is B, so only two are involved here. So it can be very easily seen that we have only two inputs. So we have A and B here, and the signals from them are, this is A, this is B. So what has been performed here, initially the product of AB and the complement of them will be added together by using this OR gate. Okay, so we can see that this is the OR gate. So here we should have first, okay, we will have this AND gate, and through this AND gate these two inputs will be given, and here we will have what? AB. Okay, so after it, as this is the input, after it what we have to do, we have to apply this NOT gate in order to get the complement of it, and in order to get the complement of it we will get AB whole prime. So again we have AB prime and AB as well, and those two are what? Those two are added together, just like here. So what we have to do here, we have to use this OR gate as well. So here we should have this OR gate to which AB prime and AB should be given as given here, and it will give me what? AB plus AB whole prime. So do I have this signal here? Yes, it is already here, and that is basically this one. Okay, and similarly AB prime is also here, and this is connected here, and we will get this output which is shown here. Okay, so that is the solution of part A here, which I have to perform. Okay, so that is the solution of part A. Similarly for part B, here we have A, B, C, D. So this one is also very easy, in which we have to find the inputs first. So we have four inputs here which are A, B, C, D. So A, B, C, D. Okay, these will have first, second, third and fourth signal. Okay, and here we will have to multiply them together in order to get the answer. Okay, so that is the product of them, and it will be what? It will be A, B, C, D. Okay, so that is the answer of part B. Similarly for part C, we have A plus BC. So let me move down. So we have here, we can see that we have A plus BC. So C is A plus BC. So here we have three inputs, A, B, C. Okay, so what do I have to do here? First of all, I have to multiply them together, and then I have to add the product of BC with this A. Okay, the same as we have done previously. So the first gate I will have here. So first the inputs are here, and the first gate we have is the AND gate. Okay, so that is the AND gate, and here we will have what? There we will have these BC. So at the end here we will get BC. Okay, so with this BC I have to add A. So for it I have to use this OR gate here. Okay, and it will have two inputs. Here I should have A and here I should have BC. Okay, so this will be connected here, and here I will get A plus BC, which is the output of my circuit, which has been given A plus BC. Okay, the last one is D. So let me write it here. Part D is ABC plus D. Okay, so that is the same question which we have previously done, so I am not going to do it again. So initially let me give you the idea here is that here ABC, these three will be multiplied together by using the AND gate. Okay, and this AND gate will be given with this OR. So this D and this ANDed output will be OR together to give me this output. Okay, so that is the solution of this question, in which we have solved all the relevant examples which we have to solve here. So that is the end of our question here, and I hope all of the steps which I have taken here would have been cleared. So thank you so much, and I will see you with some more examples in our upcoming video. See you soon. So this is question number 16, and we are going to discuss part A of it, in which we are asked to draw a logic circuit for the case where the output enable is high only if the inputs assert and ready are both low. Okay, so suppose we have here a circuit like this one. Okay, and the inputs it has are the assert and low. These are basically the two inputs, and the condition which is given here that the output which is here the enable, it will only be high if and only if assert and ready both are low. Okay, so the case where both of them will be low we have to mention here. So let me write their conditions here, just like this is assert, this is low, and this is enable. Okay, so what are basically the combinations which are giving me the outputs? So the combinations we have here are 0 0 when both are low, when assert is low while low is high, when assert is high while low is low, and when both assert and low are high. Okay, so according to the condition mentioned here, the only way the enable will be higher will be when assert and low will be low. Okay, all other combinations of assert and low will give me what? Output equal to 0. Okay, so what we have to do, we have to draw a logical diagram for this condition. Okay, so in order to do it, what are the first step? First of all, we have to make a diagram for it, and after it we have to write about it by using this truth table. What is this? This is a truth table. From the truth table, what we have to do, this is a first, this is second step, and in third step what we have to do, we have to write the Boolean expression for this diagram. Okay, so we have to write the Boolean expression, and for writing the Boolean expression what we have to do, so we have to use the concept of the sum of products. Okay, so that is SOP. So what are the sum of the products in which we have to take all the entries where the output is what 1. So the only entry we have here when the output is 1 is this one. Okay, so this is the entry which we have to encounter in sum of product rule. So what we have to do, we have to make assert and low equal to 1. So for it, what we have to do, we have to take the complement of both of them and their product will be equal to 1. Okay, so let me write it here. So here we will get what? Assert multiplied by low and also the complement, and this will be equal to what? This will be equal to 1. Okay, it will always be 1, and this is basically the not basically the sum of the products, because here we have only one product, and the complement of this will basically give me the output, which is the enable, which is already 1. So as we don't have any other products here, so we are going to write it just this one. Okay, so after it, what we have to do, the fourth step here is the, let me move down some. So now here logic circuit. Okay, so from this Boolean expression we have to draw the logic circuit diagram. So from it we can very easily see that this is what, this is dot. Okay, so as this is the product, so what we can do, we can use this AND gate. So to AND gate we are given two inputs, which are assert and low. These two are given to it, and the output we are getting assert multiplied by low. Okay, and then these are given to the inverter or NOT gate, and out of the output we will get assert dot low whole complement, and that is what, that is the output. But here we can very easily see that this is the AND gate and the connected gate with it is the inverter. So you basically, this one is this one. Which one gate is this? We can see that this is basically the NAND gate. Okay, so to NAND gate, when these two inputs are applied, the output will be this one. Okay, this will be the output, and these two will be the inputs which will be provided here. Okay, so that is the solution of our question, in which we have seen that how to draw any logical circuit from the statement which are given to us, and that is the essence of any digital logic design circuitry. We will extend our knowledge in our upcoming lecture, so till then please practice or all this, but the essence of it are these 4 steps. First of all you have to draw the simplified diagram, then you have to write the truth table. From the truth table you have to write the Boolean expression from the sum of the products or products of the sum procedure, which we will discuss in our upcoming lectures, and from it you can also draw the logic diagram, which will be very easier once you have defined the Boolean expression for it. So that's it for today, and I will see you with some more interesting questions in our upcoming video. Till then, take care of yourself. So this is question 16 part B, and here again we are going to draw a logic circuit for the case where the output hold. Okay, hold is the output is high only if the input load is the input and ready is the input as well. So when load is low and ready is high, so in this case the output, which is hold, will be high. Okay, so the first step for this question will be the same which we have done previously. So step 1 here will be drawing the simplified diagram. Okay, so the simplified diagram for it will be, this is the block, and here we have 2 inputs. Okay, what are those inputs? Those are basically load, okay, and ready. ready and load are two inputs which are giving me a single output, which is hold. This is the step number 1. In step number 2, what we have to do, we have to draw the truth table for it. So, okay, so that would be the truth table. Okay, so in truth table, what would we have? We would have two inputs which are load and ready. Okay, and the output we will have is this hold. So this is what we have. Okay, so we can see that this would be a truth table. Here we have to write all the combinations which this load and ready will have or could have. So load and ready could be both low. Load can be lower, ready can be higher, load can be high, ready can be low, and both of them can also be high as well. So what is the condition here? So this load, this hold will be high only if the input load is low. So load is low in these two cases and the input ready is high. So this will be the case when it will be what? This will be 1, otherwise and in other cases it will be 0. So this is the truth table, which basically explains very comprehensively the statement of this question. So this is the step 2 of any digital logic design circuit. In step 3, what we have to do, we have to write the Boolean expression. Okay, so writing the Boolean expression for it involves what? Sum of the product or product of the sum of the products or products of the sum. Okay, so in order to do the sum of the products, what we have to do, let me use the sum of products here because this is the easier one and we haven't even discussed both of them, but let me use the sum of product. And here we have to identify the inputs for which the output is what? Output is high. So what is that? This is this entry. Okay, so as I have previously told you that after identifying it, what we have to do, I have to make both of them equal to 1 so that the corresponding output will be 1 from the product of the inputs. Okay, so here let me write them. Here load is what? 0 and ready is 1, which is already 1. So I have to make this load complement and with it I have to multiply the ready and from it I will get 1. So this is the expression and we can very easily see that there are no other products here. So only one product will remain here, which is basically giving me this only one AND gate. Okay, this is the AND gate and this complement is basically shown to me by the NOT gate. So only two gates will do the purpose. Okay, so this is the one gate, this is the second gate, and this is basically the expression which we were needing here. So step 4 here is the logic circuit diagram. Okay, so how many inputs do I have here? I have two inputs, which are the load and ready. So load and ready, and both of them are applied to the what? To the AND gate, and prior to the application of their product, load is what? Load is complemented. So this is load, this is ready, and initially this load is complemented. So I will get here what? This is load complement, and what is this? This is the ready signal, and both of them are now applied to the AND gate. Okay, so this is one input, this is the second input, and from them I will get what? Load complement, and this is multiplied by this ready. Okay, so that is the end, in which this is the only circuit which will explain and do all the stuff which is now given in the form of this truth table, and also in the form of what, in the form of this statement as well. So again, in this question we have summarized all the steps which are needed for, which will be needed for the more complex circuits as well. So this is one of the very simplest circuit we have, and by writing all the statements in the form of a truth table, you can write the Boolean expression, and from the Boolean expression you can design any logic circuit in the way which we have mentioned here. We will also move towards more complex circuits in our upcoming videos. So you are requested to practice over all this stuff, and please write in the comment box if you encounter any difficulty during your practice. Okay, so take care of yourself, and I will see you soon. So this is question number 17, and here we are asked to develop the truth table for each of the following circuits in figure 4.58. okay, so this is figure 4.58, and today we are going to solve part A of it. Okay, so before proceeding to solve the circuit which is mentioned here in part A of it, let me first make some assumptions here. In order to simplify it, let me call this input VCR is A, okay, cam I as B, okay, and this RDY already, let me call it C. Okay, and we have this output here which is record, so let me call this record equal to out. Okay, so that is the output, that's why I'm calling it out. Okay, so now here we can see that here this VCR which is input A, and this cam I which is input B, these are applied here to this NOR gate. Okay, so before the application of them, these are basically given to this bubble, and this bubble is basically the representation of a NOT gate. Okay, so this is the representation of a NOT gate. Okay, so now here we can see that both of these are applied here. So now let me use this white color for it. So when both of these are applied here, so before them these are given to the NOT gate, so here A is complemented, and therefore cam I which is B now is also complemented, and then these are given to this NOR gate. Okay, so according to the processing of this NOR gate, this will be added, okay, and whole complemented. So this is the output which we are getting from here. So here the output will be A prime plus B prime whole complement. Okay, so this is what we have obtained here, and again it is now applied here at this point. So let me use this color here. So this is again now applied here. So we can see that this is applied here, and this RDY which is also C is also given to this bubble, so it is also complemented. So this will become C prime, while here when this will be applied here, let me use this white color again. So this is now applied here, it is again complemented, and we can see that the complement of a complement is no complement. So A prime plus B prime. Okay, so this will be the output here, and with it this C prime is applied, and both of them are applied to this. What this is basically the NAND gate. Okay, so this will be multiplied with this C prime because of this bubble here, and at the end here we will get this whole prime because of this NAND operation. So here it will be the output which we have got here. So after this, this is what, this is the expression which we have obtained. So this is the expression, okay, for what, this is the expression for our output. Okay, so this is also record. So this is the output here. So now on the basis of it, let me write here the truth table or draw a truth table. So here we have some inputs, input A, B, C, okay, and here we have this out, okay, and here it will be like this. Okay, so now writing all the possible combinations of A, B and C. So here it will be 0 0 0 0 0 1 0 1 0, okay, and 0 1 1. Similarly 1 0 0 1 0 1 1 1 0, and the last one here will be 1 1 1. Okay, so now each of them is applied here, where the output is basically this expression. Okay, this is the output, and here I want to find out the output on the basis of it. So here when both of this 0 0 are applied here, so this will be A is 0, B is 0. Okay, so A complement will be 1, B complement will also be 1, so 1 plus 1 is 1, and multiplied by 0, so 0 complement is again 1, so 1 1 is 1, and the complement of it is now what? This is now 0, so it will be 0 here. Okay, similarly now here A is 0, B is 0, so 0 complement is 1, B complement is 1, 1 plus 1 is 1, okay, multiplied by C complement, so C complement is C is 1 here, so it will be 0, so 0 will make all of this 0, and the whole complement of it will give me 1. Okay, similarly A is 0, okay, and B is 1, so A is 0, so A complement is 1, B complement is 0, so 1 plus 0 is 1, multiplied by C complement, so C complement is now 1, so 1 1 is 1, and the whole complement of it will be 0 here. Okay, similarly here 0 will be given here, so 0 complement and 1 complement, so 1 plus 0 is 1. Okay, and this 1, so 1 complement will be 0, so 0 will make all of this equal to what? 0, and the whole complement of it will be 1 here. Okay, similarly this is now for this one. Okay, sorry, I have written it somehow in incorrect order, so before it, let me write it here. So this is 1 0 0, so A is 1, so complement of it is 0, this is 0, so complement of it will be 1, so 1 plus 0 is what? 1, and this will be 0 complement, so 1 multiplied by 1 is 0, 1 multiplied by 1 is 1, and the whole complement of it will be 0, so it is 0 here. Now here in this part, 1 complement is 0, 0 complement is 1. Okay, so I will get 1 from here, and 1 complement is 0, so it will make it 0, and the whole complement of it will be 1 here. Okay, so here we will get that 1 complement 0 plus 0, and multiplied by C complement, which is 1, so 1 multiplied by 1 is 1, and the complement of it is what? Sorry, this is 1 complement, so 0, 0 multiplied by 1 is again 0, and the whole complement of it I will get here 1 as well, and here from this expression I will also get 1. Okay, so this is the truth table which we have developed from this expression, which is the expression for the output, where this one is this record, and here it is out. So here we got our output from this expression, and this is the only way of finding the output, in which I have to first find out the expression or Boolean expression of any output variable, and on the basis of that I have to find the output for all the possible combinations of the inputs. Okay, so that's it for today, in which we have discussed this question, and in our upcoming video I will discuss this part B. So till then, take care of yourself, and I will see you soon. This is question number 17, and today we are going to solve part B of it. Okay, here we have this circuit in which the inputs are RTS and enable, and another input we have this busy. Okay, so let me again represent them with some other variables in order to simplify our question here. So this is part B of our question, and here let me call this RTS equal to A. Okay, enable, let me call it B. Okay, and let me call this busy this is C. Okay, the output is now sent. Let me not change it, and it is the same output we have. So now in order to do it, let me use this one. Here we can see that this RTS and enabled are applied to this NAND gate. Okay, so the output of them will be A dot B whole complement. So this will be the output which we will get here. Okay, here prior to the application of these inputs to this NAND gate, what we have here two these bubbles. Okay, so what is the functionality of these? So as I have previously told you that this bubble basically represent the inversion of the input which is applied to them. Okay, so therefore when this input is applied to the bubble, what I will get here, I will get here AB complement, and it is again complemented. So therefore these complements will cancel each other and I will get here AB. Okay, this will be here, while this BZ is C, so therefore it will be now here C complement, and both of these are applied here to this. What, this one is the NAND gate, so therefore I will get here AB multiplied by C prime and whole complement. So this will be the output, and here this output is what? This is the output which is called SAND. Okay, so what is this? This is the output, required output, which we have got from this circuit. So this will be the output or the expression, Boolean expression of the output which we will get from here. Okay, so after it, what is the next step? Here, in order to find the output of it, we have to write all the combinations of them. So let me write here A, B, C, and here we have this output SAND. Okay, so this is what this is we have here and here as well. And now writing all the possible combinations of input. So it is 0 0 0 0 0 1 0 1 0 and 0 1 1. Similarly here 1 0 0 1 0 1 1 1 0. Okay, and here 1 1 1. Okay, so now in order to write the outputs here, what I have to do here, we can see that this 0 multiplied by 0 is 0, and here again C prime is multiplied, so 0 multiplied by anything is 0 here. So from here we will get 0 and the complement of it is 1 here. Okay, so we can see that it is 1. Okay, similarly here 0 multiplied by 0 is 0. Okay, in this expression, and the complement of this one is again 0, so here it will be 0 again, and here again 1. Similarly here we will also get 1. Okay, here it will be 0 and it will also be 0 and the complement of it will be 1. Okay, similarly 1 multiplied by 0, so it will be 0, and 0 multiplied by anything will also be 0 and the complement of it will also be 1. Similarly here as well we will also get 1. Now here we can see that it will be 1 multiplied by 1 is 1, and C complement is what? C complement is again 1, so 1 multiplied by 1 is 1 and the complement of it is now 0. So we can see that these are only the single inputs which are giving us this 0 up till now. Similarly now here 1 1 is 1 and the complement of this one is 0, so 0 multiplied by anything is 0 and the whole complement of it will be 1. Okay, so this is basically the output. Okay, I have somehow tilted it, but you may see the concept here that what it will be. So this is the output which I have got from this Boolean expression. So this is the Boolean expression, okay, or the resultant Boolean expression which we have obtained from this part. So that's it for today, in which we have solved the part B of our question number 17, and I will see you with some more questions in our upcoming video. Till then, take care of yourself and I will see you soon. So welcome back guys, this is section 4.5, and we are going to solve question 19 of it. Here we have different parts, and in these parts we have to use the Boolean algebra techniques to simplify the following expressions as much as possible. Okay, so here we have this part A, and here we have this expression A and A plus B. Okay, so what we have to do, according to the distributive law, we have to multiply A with all of these terms which are inside this bracket. So this A dot A plus A dot B. Okay, so what it will be equal to, this A dot A is equal to A, okay, and this A dot B is like this one. So how would we do it? It is because A dot A is equal to A. So this is due to this law. Now here we have this one, and taking this A common from here, what we can get, A is common now, so 1 plus B will remain here. Okay, so from it we can very clearly see that 1 plus any literal here or any variable here will give us what? Will give us 1. Whatever here will be, it will give us 1. So here what I will get? I will get 1. So the simplified form of it will be this A. So this is the answer of part A. Okay. Similarly, part B, here we have A prime plus AB. Okay, now again using the distributive law here, multiplying this A with all the terms which are inside this bracket here. So A dot A prime plus A dot AB. So here what we have here, A dot A prime is always equal to 0 according to the Boolean law, and similarly A dot A is always equal to A. Okay, so using these two laws here, what we will get here, we will get 0 plus this AB. Okay, which will simply be, because now here 0 plus anything here will give me that thing. So here we will get what? We will get here AB, and that will be the simplified version of this equation according to the Boolean expression. So this is part 2 of my question. Now let me move down. So part C, here we have BC plus B prime C. Okay, taking this C common from here, what we will get here, we will have B plus B prime. Okay, and according to the Boolean algebra, A plus any of its inversion will always be equal to 1. Okay, it will be equal to 1. So therefore this B plus B complement is also equal to 1. Okay, so therefore at the end 1 multiplied by C will be equal to what? This will be C. So this is the simplified version of this question, which is question number C. Okay, this is part C. Similarly, part D, here let me solve this part D. So part D is A plus A prime B. Okay, so this is basically question, and let me move down here to solve it. So here now, using the distributive property here again, let me multiply this term with all the terms which are inside of this bracket. What I will get, A dot A plus A dot A prime B. Okay, is it the same question or what? No, it is I thought that B and D are same, but now it is different. Okay, yes, this is different. So now as I know that A dot A is what? This is always equal to A, and A dot A prime is always equal to what? A dot A prime of it is always equal to 0. So according to this law, here we will get 0 dot B. Okay, so here we will get A plus 0 multiplied by anything will be 0. So here we will get this A. So A will be the answer here, which is the simplified version of this part D. Okay, so that's it for today, in which we have solved up to part D here. So to solve part E, it is your work to solve it by using all the forms, all the formulas which we have followed here, and I hope it will be easier for you to solve these type of questions. We will also try to solve it in our upcoming video as well, but it is now your task to solve it by following all the rules which we have followed here. So I will see you with some more questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 20, and here we are asked to find the simplified version of these expressions by using the Boolean algebra. Okay, so let us solve the part A first. Okay, so let me use this white color for it, and here we have the expression a prime plus c, okay, and a plus c. So this is the expression that we have. So now, according to the associative law, what we have here, so we can also write it like a prime a plus c, okay, and also c a plus c. Okay, so this is the version we have. Now multiplying these terms with the terms which are inside these brackets, so what do we get here? So we will have a prime dot a, similarly a prime dot c. Okay, now multiplying this term with all of these terms here, so we will get ca, okay, and also c dot c. Okay, so now here we can see that we have different terms like this one, okay, and this one as well. Here we can see that very easily that according to the Boolean algebra, a dot a is always equal to 0, and similarly c dot c is always equal to c. Okay, so now using these relationships inside our expression here, what will we get? Here we will get what? Here we will get 0 plus a prime dot c, okay, similarly here c dot a, okay, and here what? This would be c. Okay, so ultimately we will have here a prime dot c, similarly it can also be like a dot c here, and it will be c here. Okay, so we can see that here we have c, 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 so this c term is constant here or common in all these literals. Okay, so taking it common here, what will we get? So taking this c common here, what will we get? This will be a prime plus a and plus 1. Okay, so it will be here. Okay, so according to the Boolean's algebra, what do we have? We have, let me move down further. So what do we have here? If we add this 1 with any term, 1 plus any term x, what will we get? We will get 1. Okay, so every term with which this 1 is added, we will get 1. So here this 1 is added with these two terms. Okay, here we have a prime plus a, and also according to the Boolean's algebra, we have x plus x prime, this is always equal to 1. Okay, so using these relationships here, what would we get? We will get here c equal to a prime plus a is 1. Okay, similarly this one here. Okay, so what do we get from here? We will have c multiplied by 1, and at the end we will get here this c. So the answer here is this c. Okay, so c is the answer of my question, and this is basically the simplified version. This is the answer of part A which we have. Now in order to solve the part B here, what do we have? Let me solve this part B here. So what do we have here? We have this expression in which we have a b prime plus a b prime c plus a b prime c d, okay, and also a b prime c d e. Okay, so here we have all these terms, and we can very easily see that in all of these expressions, what we have a b prime, a b prime, a b prime, a b prime. So this prime is basically the complement of the literals upon which it is used. So therefore let me take this AB prime common here. So taking this AB prime common, so AB prime, so what do we get? This will be 1 plus C plus CD, okay, and plus here CDE. So despite going any further, we have an expression like this one here, where we have shown you guys that if 1 is added with any expression, at the end we will get what? We will get 1. So here we can see that this 1 is added with all of these expressions, okay. Let me clearly mention it, this 1 is added with all of these expressions. So therefore here we will have AB prime, and this would be 1, and ultimately we will get here AB prime, okay. So the answer of this is AB prime. Welcome back, guys. So this is question 20, and here we are asked to find the simplified version of these expressions by using the Boolean algebra. The part C, here we have this one is BC plus BCD whole prime plus B. So let me use it here. So we have here BC plus BCD whole prime plus B. Okay. So now before proceeding to solve this question, we have here 3 terms, and upon these three terms we have this whole complement. So according to the De Morgan's theorem, what do we have? If we have x, y, z whole complement, so it is equal to the x complement plus y complement plus z complement. This is what? This is the De Morgan's law. Okay, so according to the De Morgan's law, we have this expression. So now by using De Morgan's law, let me simplify it. So simplifying it, what will we get? We will get here BC plus these terms will be what? Here we will have B prime plus C prime plus D prime, and here we have this B. So we can very clearly see that this is because of this term here, and these are the terms which are constant. Okay, so let me move down further. So now we have here BC plus B prime plus C prime plus D prime plus B. Okay, so let me rearrange them, and rearranging them, what will I get? I will get here BC plus B prime plus B, and similarly C prime plus D prime. Here we can see that these are the two terms, and according to the Boolean's law, what do we have? If we have literal x and with it we have added x prime, so it will be always equal to 1. Okay, so making it 1, what I will get here? I will get here BC plus 1 plus C prime plus D prime. Okay, so with all of these terms, this 1 is added now. So therefore at the end we will have the expression which will be this one, because here according to this theorem which is written, anything which is added with this 1 will ultimately give me 1 here. Okay, so it will give me this 1. So this is the solution of part C here. So let me again see the part D. So the part D, here we have B plus B prime, B plus B prime, and with it what is multiplied? BC plus BCD prime. Okay, so here this expression we have, and according to the Boolean's law, which we have previously seen, that here it is written that x plus x prime is equal to 1. So let me again write it here. So x plus x prime is equal to 1. So therefore this expression will be like 1. Okay, so this 1 will be multiplied with this BC plus BCD prime. So ultimately it will give me what? It will give me BC plus BCD prime. Okay, so from here we can also see that this BC and this BC is common in between them, and let me take it common from them. I will get BC. So here I will have 1 plus D prime. Okay, so again according to the expression which is here, let me see the expression here. So according to the expression which is here, this one, we have 1 plus x equal to 1. So writing it again here, we have 1 plus x prime is also equal to 1. Okay, so using it here, what will we get? We will get BC multiplied by 1, and ultimately it will give me this BC. So the answer here is this BC. This is the answer of part D here. Okay, so the answer of part D is this one. So now let us proceed toward the last part of our question. So the last part we have is this one, and that is BC plus B prime plus C prime D plus BC. Okay, so let me write it here. So this is part E, and in part E we have what? We have BC and plus at the end we also have a BC. So B plus C prime multiplied by D. Okay, so we have here these terms. So according to the law, we have these two terms which are same, and we can also see that whenever we have x plus x, the output of it will also be x. This is also the Boolean law. Okay, so rearranging them, and we will see that representing these two terms with the same term here, what will we get? Here we will have BC plus B plus C and here D. Okay, so this is the term which we have here, and we can also multiply it with all these terms, this D, and what will I get here? I will get here BC plus BD plus C prime D. This D is multiplied with all the terms which are inside this bracket, and here we can very easily see that this cannot be further simplified because this is the final version. Okay, so the simplified version of our equation here is this one. Okay, or we can also take this B common from here, or the same expression here, this can also be used here, but these two are basically the simplified versions which cannot be any more simplified. Okay, so most probably here we can see that this is the simplified one, while this expression is having the two multipliers and also the simplified one. Okay, so both of these can be used, but the only thing here we saw that the use of these BC in a single term. Okay, so that's it for today, in which we have seen the solution of problem 20 in our book. So in here we have used the Boolean algebra to solve all the expressions and all the sub parts of our question to simplify the Boolean expressions which are given to us. Okay, so I hope you have understood it, and if you got any difficulty in understanding these questions, please ask me in the comment box. I think it's enough, so we'll see you with some more questions in our upcoming video. Hello guys, this is question 21, and here we have to use the Boolean algebra to simplify the following expressions. Okay, so the part A of our question is given here, and that is CE plus C E plus F plus E complement E plus Z. Okay, so let us start solving it. So before solving it, what we have to do, we have to multiply this C with all the terms which are inside this bracket, and also this E with all the terms which are inside this bracket. Okay, so let me multiply them, and what I will get here, I will get here CE plus CF. Okay, similarly E prime dot E plus E complement or E prime G. So here what do we have? We can see that this term and this term, these are two similar terms. Similarly here also these two terms, and one of them is the complement of it. So what do we have to do? we know that according to the Boolean algebra, what we have, x plus x is always equal to x, and similarly x dot x prime, this is always equal to 0. Okay, applying this theorem here and this one here, what do we have? We will have here CE. Okay, because these two terms will be represented by a single term here, and similarly CF, and here we will have 0, and here E prime G. Okay, now after it, what would we get? We would get CE plus CF plus E prime G, or taking this C common, we can see that here this C, this is common here. So taking it common from here, what will we get? We will get here E plus F, and also here E prime G. Okay, so what is this? This is the simplified version, and it cannot be simplified furthermore. So this is the answer of part A of our question. Similarly, part B of our question is here, which is given. So here we have B prime C prime D plus B plus C plus D whole prime whole complement plus B prime C prime D prime and E. Okay, so here we have this term. Okay, and according to the De Morgan's law, what we have, if we have x plus y plus z whole complement, so what would be, what it can be? So in a simplified version, it can be x dot y prime dot z prime, and it is by the De Morgan's law. So according to De Morgan's law, this is the expression. So now applying it here, what will we get? We will get here B prime C prime D, and similarly here we will have B prime dot C prime and D prime, and plus B prime C prime, and here D prime and E. Okay, so here we can very easily see that B prime C prime is here, it is here, it is also here. So let me take this B prime C prime common from it. So before it, or before taking this common from here, let me take B prime C prime D prime common from these two expressions. Okay, so let me take it common here. So it would be B prime C D plus B prime C prime D prime, and here it would be 1 plus E. Okay, so according to the Boolean's law or Boolean's algebra, 1 plus x is always equal to 1. So applying it here, so what will I get? I will get B prime C D plus B prime C prime D prime, sorry, this is also C prime. So here I will have this 1. Okay, or it will give me what? B prime C prime D prime plus, sorry, this is not D prime, let me move it, or it will be B prime C prime D prime. Taking this B prime C prime common from here, what I will get, because here I can very easily see that this B prime C prime is common in between these two terms. So taking it common here, what I will get? I will get here D plus D prime. Okay, so let me move down somehow. So here I can see that according to the Boolean's algebra, we have x plus x prime, this is always equal to 1. So it will be equal to what? It will be equal to 1. So here we will have b prime c prime multiplied by 1, and 1 multiplied by anything will be that thing. So the answer we will have is b prime c prime, and this is the simplified version of our part 2 here. Okay, so this is the simplified version and this is the part B of our question. For other parts, for other questions, I will solve it in our upcoming video, because for today these two parts are enough, because we have solved them and it is mandatory for you to practice other parts which we will also solve in our upcoming video. So for today it's enough, and I hope these questions will give you the intuition that how to use the Boolean algebra to solve or to simplify the expressions. So that's it for today, and I will see you with some more parts of this question in our upcoming video. Till then, take care of yourself and I will see you soon. Welcome back, guys. So we are back with our question 21, and here let us solve this part C of it. Okay, so as we have promised, we are going to solve this part of it today. So let me use this one. So we have here c plus cd and multiply it with c plus c prime d and c plus e. Okay, so we have this expression. Here we can see that very easily this c is common in between these two. So let me take it common here. So by taking it common, what I will get here 1 plus t, and all the terms will remain same. Okay, and c plus e. So what is this? As we have previously seen that according to the Boolean algebra, 1 plus x is always equal to 1. So it will be applied here. Okay, it can be applied here, and we will see that we will get what? We will get c multiplied by 1. Okay, and here also we have c plus c prime d and c plus e. Okay, also we will see that we can see that this is c, and here we have c plus c prime d and also c plus e. Now taking this term, this c, and multiplying it with all the terms which are inside here. So what will I get? I will get here, let me solve it here. I will get here c dot c plus c dot c prime d. Okay, so it will be here, and here we will have c plus e. So now according to rules of the Boolean algebra, what we have here, we can see that x dot x is always x and x dot x prime is always 0. Okay, so now applying it here, what I will get, applying this rule here. Okay, and here we can apply this rule. Okay, so what I will get here, let me write it here. I will get here c, and also here I will get 0 dot d. Okay, and here we will have c plus e. Okay, so now this will also become 0. This will also become 0, and 0 plus 8 will also give me this c, and here I will have this c plus e. Okay, so now this is the simplified expression, because if I will open it and try to simplify it, at the end I will also get this one, but I think this is the simplified version and it cannot be more simplified. So here we have the simplified expression which is written here. So this is the answer of what? Part C here. Okay, so this is the answer of part C. Similarly, now we have some other questions, and I strongly encourage you guys to solve this part D and part E as well, because these are the two very easy parts of our question. So if you guys find it difficult to solve it, please ask me in the comment box to solve it for you as well, because I found these two parts very easy, because you can use here what? De Morgan's law. De Morgan's law will be used here, and similarly in part E here, what do we have to do? We have to open these, okay, brackets, and before opening these, what we have to do? We have to multiply this d prime with this, all these terms here, and at the end, first we have to open this these small brackets, and at the end we have to open these square brackets. Okay, so I think these questions are now easy for you to solve. If you also found them difficult to solve, please ask me in the comment box and I will solve them as well in our separate video. So that's it for the Boolean algebra for the expression simplification, and I hope it's enough for today. And from our next video we will proceed to the other questions of our book. So I think it's enough for today, and I will see you with some more examples and some more interesting questions in our upcoming video. Till then, take care of yourself and I will see you soon. Welcome back guys, this is question 22 of our book, and here we have to determine which of the following logic circuits in figure 4.59 okay are equivalent. So this is figure 4.59, and here we have different parts: part A, part B, part C and part D. Okay, so here we have to find them, that which of them are equivalent. So in order to do it, what will be the strategy we will be following here? We have to find out the Boolean expression for each of the logic circuit here, and we will have to simplify it if it needs to be further simplified, and then we have to see that which of them are equivalent. Okay, so in order to do so, let me start it by writing the expressions for each of the part here. Okay, so let me start it for part A here. So in part A we have different inputs, which are C, D prime, B prime and A. Okay, so here at this end, what is the output? This is the AND gate, and here we have the output CD prime. Okay, and here we have this B prime. So here this is OR gate. With this OR gate, this CD prime and this B prime are given. So here we have B prime plus CD prime, this is the output here. Okay, and here again we have this one AND gate. To this AND gate we have two inputs. One input is this B prime plus CD prime, while the other one is this A. Okay, so with this, what is this? This A will be multiplied with B plus C D prime. Okay, this will be the input to this OR gate. Okay, but the second input to this one is here from this AND gate. Okay, so what is that? Let me write it here. That is A prime B prime C. Okay, so this is given here to this OR gate, and at the output, what would we get? Let me write it here. The final expression we will have will be A B plus CD prime, and with it the added one is what? A prime B prime C. Okay, or let me write it here as well. So let me write it here for this A B plus C D prime, and with it what we have added? We have added A prime B prime C. Okay, so this is the expression, and let me highlight it by using this. This is the expression for my part A. Okay, we have to see that whether we can further simplify it or not. So writing it or simplifying it, what we have to do, let me open up this bracket, and what we will get here, we will get here AB, okay, plus AC D prime, and similarly A prime B prime C. So this is the expression which we have got from this one, and I think we cannot further simplify it. So therefore this is the final expression for part A. Okay, similarly for part B, here we have this part B, and in order to find the simplified expression for it, what we have to do, we have here 1 2 3 AND gates, and the outputs of each AND gate are, for the first one this is AB prime. Okay, for the second one what we have here A C D prime, and for the third one we have A B prime C. Okay, so these three are applied to this OR gate, and at the output what would we get? Let me write it here. This X will be equal to AB prime, okay, similarly plus AC D prime, and similarly AB prime C. This is the output. So let me compare it with the first one here. So we can see that this is AB, so these two are, so AB prime is here, ACD prime here, but here we have this A prime, while here it is AB prime C. Okay, so what we have to do, let me also identify it. This is part B of our question. For part C, this is part C with us, and here in order to solve it, what we have here, we have these three gates, and at the end we have this OR gate. So the output of each gate here is, this will be CD prime, and here this B prime is applied, so here we will have B prime C D prime. Okay, and here we will have AB prime. Okay, so the output what we will get, these two are the inputs to this OR gate. Okay, so we will have B prime C D prime plus AB prime. Okay, so this is what, this is the output of part C. Okay, so this is a circuit, and the output it has is this one. Similarly for the last part, this is part D, and for this what we have here, this is AB prime here, the output of this gate is AB prime, which are the inputs here, and similarly here we have AC D prime. Okay, similarly now these two are applied to this OR gate, and at the end we have got here what the expression for X is, what AB prime plus AC D prime. So what is it? This is the output, and here it cannot be further simplified. Okay, in this question, or in these three parts, we have these three parts. This is part A, this is part B, this is part C, and this is part D. Okay, we can very clearly see that none of the expressions here are equivalent, so therefore none of these gates or none of these logic circuits are equivalent. So let me write them here. So the answer of it is none of the circuits are equivalent. Okay, so this is our question, and this is the solution which we have to find out. So from it we have seen different parts of it, and we have seen that how to calculate or see that which of the circuits are equivalent or not. So that's it for today, and I will see you with some more interesting questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. This is section 4.6, and here we have this question 23, in which we are asked to convert the following expressions to sum of product forms. Okay, so what is basically the sum of product forms? So suppose if I want to convert any of the form to the sum of the products, so what it would be? So if the output form is X, it would contain the product 1, product 2, and similarly if we have product 3 or up to the product n. Okay, what we have to do, we will have to add them together. These will be added together, and at the end we will get this one. Okay, so here we have different products which are added together, and therefore this is called, let me write it with this blue color, this is called the sum of products, or SOP. So this is called the sum of products. So we have to convert each of the expression here to the sum of the product expression. So for it, let me first try our question A. So this would be C plus D, and here we have A plus D prime. Okay, so in order to convert it, what we can do, we can also write this expression as C multiplied by A plus D, and similarly D multiplied by A plus D prime. Okay, writing it or multiplying this term with the terms inside and this term with all the terms inside, what will we get? We will get C dot A plus C dot D prime, and similarly this D dot A plus D dot D prime. Okay, so this is the expression which we have, and according to the Boolean algebra, we know that this one, okay, what it would be and how much it would be. So according to the Boolean algebra, we know that D dot D prime will be equal to 0. So it will be what? It will be zeroed here. Okay, so now writing the other terms here, what will we get? We will get AC, because C dot A or A dot C is equivalent, and similarly C dot D prime plus A dot D. Okay, so what is this? This is the term in which we have different products. So this is product number 1, this 2, this 3, and these are added together by these summations. So therefore this is the final expression, and this is the SOP form for the part A. Okay, so this is what? This is the SOP for part A. Okay, similarly for part B, here we have, let me solve it here. So for part B we have A D prime plus C. Okay, so what we have to do, again we can see that here we have this A, and multiplying this A with all the terms inside, what will we get? We will get A dot AD prime, and similarly AC. Okay, similarly we have here this A dot A, and I know that, let me write it with this yellow. So I know that A dot A is always equal to A. So let me represent it with the single element here. So what I will get? I will get AD prime plus AC. Okay, so we know that it cannot be further simplified, and here we have this product, which are basically added by using this addition. So this is the sum of the product expression, and this is the final version which we want. So this is the sum of the product expression. Okay, now let us try this last part, or let me try to solve it here as well. Okay, so the last part here we have is A plus C and CD plus AC. Okay, again using the same formula which we have used here. So here we can also write it like A CD plus AC, and also plus C CD plus AC. Okay, now we have these terms. Let me multiply with all the terms here, and let me multiply this C with all the terms here. What will we get? So we will get here ACD plus AAC plus CCD and plus ACC or CAC. These two will be similar. So now here we know that according to the Boolean algebra, what we have, we know that A dot A is equal to A and C dot C is equal to C. Okay, so using these here, this one here and this one here and here, what will I get? I will get here ACD plus AC plus CD plus AC. Okay, so now we also have here this AC and AC, and I know that according to the Boolean's algebra, AC plus AC will be equal to AC. Okay, so therefore writing it here, what I will get the final terms here. So it would be ACD plus AC plus CD. Okay, so again, what are these? This is product 1, this is 2, this is 3, which are added together, and here this is the final expression for my sum of the product formula. Okay, so we have solved different questions here. So let me separate them out. This is part A and this is part B, this is part C. Okay, this is part A. So we have solved them, and here we have seen that how to find the sum of the products of different expression by using the Boolean expression, okay, or Boolean simplification. So that's it for today, and I will see you with some more questions in our upcoming video. I hope this has cleared the concept and all the ambiguities which you might have regarding the sum of the product forms. Okay, so till then, take care of yourself, and I will see you soon. Welcome back, guys. This is question 24, and here we again have to convert each of the expressions given here into the sum of product forms, okay, which is given here. Okay, so let me start it with part B here. So in part B we have BC plus DE, and here I have to multiply them with BC prime plus DE. Okay, so let me again use the same concepts which we have previously seen. First, let me multiply all these terms with all the terms which are inside here. So let me write them here, and what I will get here BC plus DE BC prime plus DE dot DE. Okay, so as we know that according to the Boolean's algebra, we have DE dot DE, this is equal to DE. Okay, because these two will be multiplied together and we will get this DE. So here applying this one here, what I will get here, BC plus DE BC prime plus DE. Okay, so we can very easily see that this here, that this is the product 1, this is 2, this is 3. So therefore this is, these are added together by using this summation. So these are the sum of the product forms. So these are sum of products. So therefore this is the solution of our part A here. Okay, similarly now let me solve part B here. So in part B we have BC C prime D prime plus CE. So what we have here, again we have this term, and let me multiply it with all the terms which are inside this bracket. So let me multiply it. So it would be BC dot C prime D. Okay, similarly BC and dot CE. Okay, so here we have different terms because here we have this C dot C prime and here C dot C here as well. So what would we have? We know that according to Boolean's algebra, C dot C prime is always equal to 0 and C dot C is always equal to C. So let me apply them. So it will be applied here and it will be here. So applying this one here, what I will get B0D. okay, and here we will have BCD. okay, so what will happen by using this, it will become 0 because 0 multiplied by anything will be 0, and here at the end what will we get, this will be BCD. So this is the final expression which we have, and here this is the answer of my part B here. Okay, similarly for part C, let me move down further. First let me write the expression here. So I will try to write here. So this is C, and here we have B plus C BD plus C plus D prime E. Okay, so here we have this one. Let me move down. So in order to do so, we have here this C. So let me multiply C with all the terms which are here inside. So here what will I get? I will get B plus CBD. This will be the first term, and here again C, and also this E as well, because this E is also multiplied with all the terms here inside this bracket, and here we will have C plus D prime. Okay, so here we have this expression. What is here now? We have these two terms, and let me multiply them with all the terms inside of this bracket. So we will have B plus, let me rearrange it, and I will get here BCD, and plus let me multiply it with this. So CEC plus CED prime. Okay, so also here we have B plus BCD plus, rearranging it, we can also write it like ECC plus CAD. Okay, so here we have this expression, and according to the Boolean's algebra, we have C dot C equal to C. So let me apply it here, and after applying it here, what we will get B plus BCD plus EC or CE. Both terms will be similar, so I will get here CE because this is commutative law, and according to the Boolean's algebra, this OR property or AND property, both of them basically obeys the commutative property. Okay, so we get CE and also CED here as well. Okay, so now we have this term, this term, this term, this term. These are different products which are added together by these plus signs. Okay, so what we have here, this is basically the final expression, which is the sum of product of the question which is given here. Okay, so that's it for today, in which we have again seen the procedure of converting any expression to the sum of product form, and this is the question 24, and I will see you with some more questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 23 of section 4.6, and we have to find here that they convert the following expression to sum of product form. Okay, so this is question number 3, and we have previously solved it, and I will put a link of it over here. Okay, here it will be the link of this question, that how did we solve it, and the answer of them are here as a part A, B and C. Okay, so the answer of these questions are given here. So now in question 25, what are we asked to find? So we have to define the domain of each SOP expression in problem 23. Okay, so this is problem 23, and we have to find the domain and convert the expression to standard SOP form. Okay, so here we have these three questions and their solutions, and we have to find out the domain of those expressions. Okay, and also we have to convert them to the standard form. Okay, so let me first write the domain of these expressions. So the domain here, okay, so the domain for part A is what? That would be A, C, D. Okay, similarly for part B, here we have the domain is also A, C and D. Okay, and for C we have also A, C and D. Okay, why A, C and D? Because you can see here that all the terms here which are the products and are added together are composed of any of the items which are in the domain. Okay, so the domain items are basically those items from which the product terms are constituted. Okay, so this is the domain. Okay, so these are basically the domains of these questions. Now after it, what we have to do, we have to standardize them. So let me write the standard form. Okay, so what do we have to do in order to convert them into the standard form? We have to look at each of the term here, just like here we have AC, CD, AD, and wherever we have the missing item, what we have to do, we have to add them with the expression which I will tell you. Okay, so here we have this AC plus CD prime plus AD. Okay, and previously we have seen that all the domain with which this solution is constituted are composed of A, C and D. Okay, so now here we can see that here in this term we have D missing. Okay, so what do we have to do? I have to add this D plus D prime, which is always equal to 1 with it. Okay, with it, what do we have? This is CD. Okay, so we can see that here what is missing, here we have A is missing. Okay, so here we have to add A plus A prime equal to 1 because this is 1. Okay, and 1 is, this is when multiplied with them, so we can see that 1 is the multiplicative identity and it will give me the same answer. Similarly here in this term we can see that C is missing, so therefore I have to write here C plus C prime equal to 1. Why did I wrote here 1? Because these are equal to 1. So this is for your understanding. So let me now remove them because I have to add them. And where do I have to add them? I have to add it here, this here, and also this here. Okay, so let me write them here. What do we get? Here we will get AC, and with it I have to multiply D plus D prime. Okay, similarly with CD prime I have to multiply this one, A plus A prime, and with this third term AD I have to multiply AD, and this would be C plus C prime. Okay, so this would be the expression. So let me now open it. So how to open it? We have to multiply this with all the terms here, this with all the terms here, and this with all the terms here as well. So let me move down somehow. Okay, so now it will be ACD plus ACD prime. Okay, similarly here CD prime A plus CD prime A prime, and also ADC plus ADC prime. Okay, so now let me arrange them. What do we get? This would be ACD, this would be ACD prime, it will remain the same. Similarly, rearranging them in such a manner that the alphabet which comes before the other one should be at the position which is higher than the previous one. So here I have to write A C D prime, and here it can also be written as A prime C D prime. Similarly here A C D, and here A C prime D. Okay, here we can very clearly see that this ACD, this ACD, these are same, and ACD plus ACD will be equal to what? That would also be the ACD. So ACD plus ACD, this is also always equal to ACD. Okay, similarly here we have ACD prime, there is no ACD prime here. Yes, this is this one is here and also here, and we can see that. Let me move down further as well. So here I will have ACD prime plus ACD prime. So according to the Boolean algebra we will have ACD prime. Okay, A prime CD prime AC prime D. Okay, so there are no other terms which are here. Okay, so let me write them here. So I will get here ACD, and this would be plus ACD prime. Okay, and plus A prime CD prime. okay, this is added together. So now I'll show this AC prime D. Okay, so what is this? This is this standard form, and we have seen that this is what we have obtained after finding. Okay, let me now write them somehow clearly. So this is what, this is the standard form of my equation, in which I can see that all the terms which were in the domain, okay, now included in all the terms. Okay, so this is the solution of part A of my question 23. Okay, so let me look at the second part of it. So this was what? This was basically the part A, and in this 25 question number 25 I have solved it. Okay, similarly for part B we will try it in our upcoming video, because it's enough for today, and I hope you have understood all the steps which we have carried out here. So in the other video we will try to solve part B and part C. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 25, and previously we have started to find the standard form of the Boolean expressions which are in the sum of the product forms. Okay, so previously we have seen that the standard form of part A of my question was this. Okay, I have solved it, and I will put a link of this video over here. Okay, so this is the link of this video. So today we are going to find the standard form of the part B of my question. So here again we can very clearly see that the domain of it is ACD. Okay, so here we have this AD prime and AC. Okay, so here we can very easily see that here we have a deficiency of C and here a deficiency of D. Okay, so according to the Boolean's algebra, we have to multiply it with the term C plus C prime, and with it I have to multiply what? D plus D prime, because these are always equal to 1. Okay, this is equal to 1, this is always equal to 1, so that's why I will have to multiply them, because when these will be multiplied by 1 I will get the same answer. So let me remove this 1 from here, and this will be added here, this will be added here. So now let me multiply them. So I will get, actually this is not the addition, but this C plus C prime will be multiplied with this term, and this D plus D prime will be multiplied with this term. Addition means this is the dialectically I have told you that I have to add these terms here, just like I have to put them here. Okay, so I have to put them here. So AD prime, with it I have to multiply AD prime, and with it I have to multiply C plus C prime, and here we have AC, and with it I have to multiply D plus D prime. Okay, so let me move down somehow, and moving here as well. Okay, so now multiplying these terms here, what I will get. So let me find them. So AD prime C plus AD prime C prime, and similarly this term here I will get ACD plus AC D prime. Okay, so now rearranging each term and making them in order of the terms which are in each product. So here I will get ACD prime, here I will get A prime, sorry, this is AC prime, D prime. Similarly here ACD, it will remain same, and here it is ACD prime. Okay, here we can very easily see that this ACD prime, this ACD prime, these are already here, and I know that ACD prime plus ACD prime, this is always equal to ACD prime. So let me make them a single item here. So I will get here ACD prime plus AC prime d prime and also ACD. Okay, so what is this? This cannot be further simplified, and we can see that each of the term here, this one, and this one, all of these terms are basically composed of all the terms which are in the domain which are ACD. Okay, so this is what, this is the standard form, and this is basically the solution or the standardized form of the sum of product expression. Okay, so this is the solution of my question here. Similarly, now moving towards the final part, so let me somehow move it to this end. Okay, so now we have this part here, and here we have to standardize it as well. So now let me start writing it here. So here we have ACD plus AC plus CD. Okay, so we can see that the domain of it is here ACD. Okay, so here we have all the terms, here D is missing, and here what, this is A is missing. So what I have to do, I have to add certain terms here. Here I have to multiply or put this D plus D prime, and here I have to put this A plus A prime. Okay, so this will be put it here, this will be put it here as well. So let me write them. So I will get ACD plus AC D plus D prime and plus CD A plus A prime. Okay, so now this is already a standardized term, but here I have to multiply this one with all the terms here inside this bracket, and also here all these terms inside this bracket. Okay, so what I will get here, I will get ACD plus ACD plus ACD prime plus CDA plus CDA prime. Okay, again rearranging them, I will get here ACD plus again ACD plus ACD prime plus here also this one will be the ACD plus A prime CD. Okay, so here we can very easily see that this is ACD, this is ACD, and this is ACD, and according to the Boolean algebra, ACD plus ACD plus ACD, this is always equal to the ACD. Okay, so therefore now writing them in the form of a single expression, and let me move somehow here so that it is clear now. Yes, it is clear now. So now I will get here what, here I will get this ACD, a single form, and with it I have to add ACD prime. This is also removed because these are added together, and here A prime CD. Okay, so this is the final form which we have got, and this is the sum of the product expression, which is the standardized. Okay, I think this standardized. Okay, so this I is not here, sorry for the spelling mistake. So this is the standardized SOP or sum of the product form, and here we have seen that we have solved all the parts of this question 25. Okay, this is a solution of this 25, in which we have seen that how to convert these parts into the standardized form. So that is the solution of question 25 here, and with question 27 I will see you in the second part or third part of this video. Till then, take care of yourself, and I will see you soon. Hello guys, so I hope all of you will be fine. So today we are going to solve question 26 of our book. Here we have previously solved question 24, and in question 26 we are asked to convert each of the SOP expression to standard SOP form. Okay, so these are the answers which we have got from the question number 24, and we have previously solved. I will also put the link of it with this video here. Okay, so this is part A, this is B, this is C. Okay, so here I have to convert each of them into the into the standard SOP form. So before it, what we have to do, let me write the domain of these. Okay, so the domain for A is B, C, D, E. Okay, for B it is B, C, D. Okay, these are B, C, D. Okay, and for C we have B, C, D and E as well. Okay, so these are the domains for each of the questions which are in A, B and C. Okay, so here let me solve only one question, and that is part A of our question, and here let me find the standard SOP. Okay, as we are asked in the question 26. Okay, so what we have to do here, we have this expression which is written, and here we have three products. Okay, so what are those products? Those are BC, okay, also B, C prime, DE and also DE. Okay, at the end what we have to do, this is part A, at the end we have to add them, and we can see that what are the deficiencies and which terms are deficient here, as we can see here in the domain. So in part BC, here we have the deficiency of DE, here all is complete. Okay, and here the deficiency of B and C. Okay, let me write commas here. Okay, so in order to convert this BC into the standard form, what we have to do, again using the same formulation, first of all let me multiply with it the D plus D prime. So from here I will get BCD, okay, and plus BCD prime. Okay, also as we can see that here in each term now E is deficient, we can see that here and here in both of terms E is not available. So let me write here what with both of them I have to write BCD E plus E prime and also BC D prime E plus E prime. Okay, so let me write them here, or let me convert and write them here. So multiplying this term here and this term here as well, what will I get? Here I will get BCDE plus BCD E complement plus BCD prime E plus BC D prime E prime. Okay, so this is what, this is the term which we have obtained for this expression. Okay, which is here for this expression, this is completed. Now for this part which is DE, let me solve it, and for it the deficient terms are what? These are B and C. So first let me write B plus B prime with it. Okay, so after it I have to multiply it with all the terms here. So what I will get? I will get DE B plus DE B prime, or rearranging it, what I will get? I will get B DE plus B prime DE. Okay, now we can see that what are the deficiencies here. We have the deficiency of C here. So therefore let me multiply here C plus C prime with both of these terms here. So what I will get? I will get BD E C plus C prime and plus B prime DE C plus C prime. Okay, so now also taking it and multiplying it with all the terms here, similarly it and all the terms here, what I will get? I will get here BDEC plus BDEC prime plus B prime DEC plus B prime DEC prime, okay. Or rearranging it, what I will get? I will get BCDE plus BC prime DE, okay, plus B prime CED, and here B prime C prime D and E, okay. So we have this equation here and it is already calculated. What at the end we have to do? We have to add, let me write this one as the equation A, this one as B, which is already completed, and this is C. I have to add what? Let me move down somehow. What I have to do? I have to add A plus B plus C. So from it, what I will get? I will get, let me write it. So the equation A is BCDE plus BCD E prime plus BC D prime E and plus BC D prime E prime, okay. Similarly, equation B is BC prime BC prime DE, okay, and equation C, which is here, that is plus BCDE plus BC prime DE plus B prime CED plus B prime C prime DE, okay. So we have these equations. So before going further, let me see that what are the terms which are equivalent. So BCDE is here, also here as well, okay. So let me write them with a single term. So let me first cross it and it will be represented by single one here, BCDE prime. So let me see that where are the BCDE prime? There is no one here. So no term like BCDE prime. So there is only single term here. So let me choose this one as well. So similarly BCD prime E. So BCD prime E, there is only one BCD prime E. So I will write it BCD prime E prime, okay. So there is no BCD prime E prime here, any other. So I will also write it. So similarly BC prime DE. So BC prime DE, there is also this one. So let me cross it and only this term will be written here, that is BC prime DE, and others are also similar. So let me write the final answer here. So the final answer of it will be B CDE plus B CD E prime plus BC D prime E, okay, this is, and plus BC D prime E prime, okay, and this one 1 2 3 4 5 1 2 3 4, fifth one here is BC prime DE, okay. Other terms are cancelled out, and the second last term is B prime CED and also B prime C prime DE prime. So this is what? This is the term and that is the answer. So this is the final answer of my question, which is now in the standard form, because all the terms here contains all the elements which were mentioned in the domain of its equation. You can see that every term here is basically composed of B, C, D, E. So, this is basically what? This is the standard sum of product form. Okay. So, that's it for today, in which we have seen that what are the steps of converting any of the sum of product form to their standard form, and we have seen all the steps which we had to follow here, and this is all about it. And for the other questions, these are left for your own practice, and this is the answer of question 26, and I hope you have understood all the steps which we have carried out here. For any question, you can write your questions in the comment box. Okay, so thank you so much, and I will see you soon. Welcome back, guys. So previously we have seen that how to find the domain of any SOP expression and also convert them to the standard SOP form. Okay, so today we are going to solve question 27, and here we have all the standard forms, the domain of these expressions and the standard forms which are written here. And in question 27 we have to determine the binary value of each term in the standard SOP expression from problem 25. So these are the solutions of the problem 25, and here we have to find the binary values of each term. Okay, so here in order to find the binary values, let me select this white color as well. So the binary value for it should be what? It should always be ACD should always be 1 1 1. Okay, similarly for the second expression here, for the ACD prime, we should have 1 1 and 0, and the complement of it will also give me 1. And for A prime CD, I will have what? I will have 0 1 0, and for it I will have 1 0 1. Okay, so these are for what? This is for this one, this is for this. Okay, this one is here, and also this one here. Okay, so these are the binary values which are written here, and this is the solution for part A of my question. Similarly for part B here, what we have to do, we have to find the binary values, and for it the binary value for ACD prime is what? Here it should be 1 1 0. Okay, for AC prime D prime should be 1 0 0, and here it will be 1 1 1. Okay, so I will have to write them as well. So this is this one is here, this one is here. Okay, let me clarify one thing here as well, because the first values here are always for A, the second are for the C, the third ones are for D as well. So the same will be followed here, same here and same here. And here we have this, here we have this last form, this one, and also we have to find the binary values. So for it the binary value of it will be 1 1 1. Okay, for it will be 1 1 0, and for it will be 0 1 1. Okay, so these would be, this is here, this is here, and this is here. These are the values, different values here, while the corresponding values of the A, C, D. Okay, for all the values these are given. So these are basically the binary values which we had to find out in order to satisfy the SOP which are given here. Okay, so in the standardized SOPs, these are the binary values which will give me output equal to 1 if any of them will be satisfied. Okay, so that is the solution of the question 27, and I hope in all of these three parts you have seen that how to convert a expression to the sum of the product, how to convert them to the standardized SOP form, how to find the domain of that expression, and at the end how to find the binary values of each of the terms in the standardized SOP expression. Okay, so this is the end of our series which we have started for these three questions, started from 23, 25, 27, and The idea behind combining all of these three is the relevance in the computation which is involved in all of these questions. So I hope all the steps are clear, and it has cleared all the ambiguities which you might have in your mind. So I will see you with some more questions in our upcoming video. Thank you so much. So welcome back, guys. This is section 4.7, and here we are going to solve question 31 here. Okay, so this is question 31, in which we have to develop a truth table for each of the following standard SOP expressions. Okay. So each of the expression is written here, and what we have to do, we have to draw a truth table for each of them. Okay, so here the part A we have, and in part A we have ABC plus A complement B complement C plus AB C complement. Okay, so we have this expression, and for it we have to develop the truth table. So what are the steps? So instead of writing all the combinations in all the variables in it and then finding the output, what we can do, first of all, let me write the domain of it. So domain of it is what? So domain of my expression is A, B, C. Okay, and after finding the domain, what we have to do, we have to write the binary values for each of the terms here. So the binary values for each of the term here is what? So first we have here A, B, C. Okay, so the binary value for A, B, C is what? That is 1, 1, 1. Okay, similarly here we have A complement, B complement and C. For it the binary value is what? That is 0, 0, 1. And for the last part, this one, the product here is composed of A, B and C complement. So here the binary number is 1, 1, 0. Okay, so these are the binary values for each of the term here. This is for A, B, C. Okay, this is for A complement, B complement, C, and this is for A, B, C complement. Okay, so after it, what we have to do, we have to write all the combinations of the variables which are in the domain of my problem here. So to write all the combinations, what we have to do, let me write here A, B, C. These are the three variables, and after it we have to write the output for them. Okay, so this is the output, and for it we have three variables in the domain of it. Okay, so let me write the values for them. So I will have 0, 0, 0, 0, 0, 1, 0, 1, 0 and 0, 1, 1. Okay, similarly 1, 0, 0, 1, 0, 1. Okay, let me move down somehow. Fine. 1, 1, 0 and at the end 1, 1, 1. Okay, so here we can see that these are the values which we have for all the combinations of my domain variables, which are A, B and C. Okay, so for it we already know that for the standard sum of product form we have different combinations which are here 1, 1, 1, 0, 0, 1 and 1, 1, 0. Okay, so what are those combinations and where are these? These are, let me denote them with this blue color. These are here. Okay, and 0, 0, 1 is here. Okay, and 1, 1, 0 is, that is here. Okay, so in order to draw the truth table for them and putting all these values 0, 0, 0 into the expression which is given here, what we can do, we have the binary values on for them. What I have to do, I have to write the values of 1 for them. Okay, 1, 1, 1, because these are the only binary values which this expression is composed of, and after it for all the other values I should have to write 0, 0, 0 and 0. Okay, so this is what, this is basically the truth table for my expression which is in part A of question 31. Okay. Similarly, for part B of my question, what I have x prime, y prime, z prime. Okay, given here x prime, y, z prime, x, y prime, z, x prime, y, z, and x, y, z prime. Okay, so let me write the domain for it. So domain of it is what? That is x, y, and z. Okay, the three variables which are already available here, and the second part is to write the binary values. Okay, so to write the binary values, here we have the first part, that is x prime, y prime, z prime. So the binary value for it will be 0, 0, 0, and this is for x prime, y prime, z prime, the first one. And for second one we have x prime, y, z prime. So here I will have 0, 1, 0, so that the product of it will give me what? 1. So it is what? X prime, y, z prime, and here we have x, y prime, z. So that would be 1, 0, and 1, and it is for x, y prime, z. Okay, x, this one, the fourth one is x prime, y, z. So that would be 0, 1, 1, and here it would be, it is what? That is x, y, z, and the last one here is x, y, z prime. So here it would be 1, 1, 0, which is x, y, z prime. Okay, so this is the expression which I have here, and for it I have to draw the truth table. And in truth table, what I have to write, let me move down somehow. So in truth table I have to write the domain variables here, which are x, y, z, and here I have to write the output for them. Okay, so this is what? This is x, y, z, and this is the output. So let me write all the possible combinations of the domain variables. So here I will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and the last one is 1, 1, 1. Okay, so we can see that we have different values which are here 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, and 1, 1, 0. Okay, so what we have to do, let me write them here. So this is 0, 0, 0, 0, 1, 1 is here, 1, 0, 1 is here. Okay, 0, 1, 1 is here, and 1, 1, 0 is okay. 0, 0, 0, 0, 1, 0, 1, 0, 1, okay, 0, 1, 1, 0, 1, 1 is also here, and 1, 1, 0. So these are the values, and for them I have to write 1, 1, 1, 1, and 1, and for all others I have to write zeros here. Okay, so this is what, this is the truth table for my expression, which is already given, and that is the resultant truth table which I have generated from the standard SOP form. Okay, so that's it for today, in which we have discussed how to describe or draw a truth table from the given standard SOP expression, and I hope it is understandable, and with some more examples, with some more questions, I will see you in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 33, and today we are going to talk about the development of truth table for each of the SOP expressions. Okay, so last time we have developed a truth table for a complete standard SOP expression. Okay, here we have some expressions which we can see that are not in the standard form. Okay, so let us talk about part A of our question, and here we can see that here we have the domain for it is, this is part A, and the domain for it is what? Domain for part A is A, B, and C. Okay, so the domain for it is ABC, and we can see that this is not in the standard form. So let me write it here. It is A prime B plus ABC prime, okay, plus A prime C prime plus A B prime C. Okay, so we have this expression, and here the missing terms are, let me write them here. The missing term is C. Here this is all terms are available. Here the missing term is B. Okay, so what we have to do, we have to use the C plus C prime here. Okay, I have to use it here and multiply it with this term, and similarly B plus B prime I have to use it here and multiply it with this term. Okay, so let me write it. So writing it, what I will get, I will have A prime B, and with that C plus C prime. Okay, similarly plus A B C prime plus A prime C prime, and with it I have to multiply B plus B prime, and with it the last term, and that is here A B prime C. So let me multiply these terms. So multiply it with all the terms here, and multiply this one with all the terms here, and rearranging it, let me write them here. So after rearranging it, what I will get, I will get here A prime B C plus A prime B C prime. Okay, similarly A B C prime plus here it will be A prime, and rearranging it I will get B C prime. Okay, similarly plus A prime B prime C prime. Okay, and this one A B prime C. Okay, so let me first find the duplicate terms if there is any available. So A prime B C, is there any other term like this one? So there is no term like this one, so this is the only one. A prime B C prime. So is there anyone else? Yes, this one is. So let me remove it from here. So let me remove it. It will remain here A prime B C prime and A B C prime. Here anyone here? No, nothing is here, so it will remain A prime B prime C and this one. Okay, so the terms here we got are the A prime B C plus A prime or A complement B C complement plus A B C complement plus A complement B complement C complement plus A B complement C. So we have these values, and in order to write the binary values for each of them, let me use the blue color. Okay, so this blue color, so the binary value for this term will be what? This is A prime, so here 0, and here it will be 1 1 0 1 1. For this term I will have what? For this term I will have 0 1 0, because he is also prime. For this term I will have 1 1 0. For this term I will have 0 0 0. Okay, and for the last term here I will have 1 0 1. Okay, so these are what? These are the binary values for my expression. Okay, so what we have to do, the domain here is I have is ABC. So in order to draw the truth table, what I have to do, let me write the domain variables. So domain variables are A B C. Okay, and with that I have to write the output. The output is here. Okay, so now let me write all the combinations of A, B and C which are possible. So 0 0 0 0 0 1 0 1 0 and 0 1 1 1 0 0 1 0 1 110, and the last one is 111. Okay, what we have to do, we have to search for all the binary values which are available here and make them equal to 1, as we did in our previous question. So 011, where is 011? Let me use the blue color as well. So 011 is this. Okay, this is 011. 010 is this. Okay, 110, this is 110, this is 000. Okay, and 101, these are. So let me write their values. So here it will be 1, it will be 1, it will be 1. Okay, it will also be 1 and 1 as well, and all the remaining terms will be 0. Okay, so this is basically the truth table which we have developed for our part A, and this is the answer of our part A as well, in which the condition is to first convert the available sum of product expression to the standard expression, and then finding the binary values, and after it developing the truth table for it. Okay. So that's it for today, and in our upcoming video we will try to solve the part B of this question, and try to understand all the steps which we have taken here in this question, and with the same condition we will start solving part B of this question in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 33, and today we are going to solve the part B of this question, and previously we have seen the steps that how to solve part A of this question. Okay, so part B of this question, for this let me select this black color. So part B of this question we have is x prime plus yz prime plus wz plus x y prime z. Okay, so first of all, what we have to do, let me first see that what is the domain of this question. So here we can see that we have x, okay, we have y, z, we have w. Okay, so the domain of this question is, domain here is what? That is w, x, y and z. Okay, so the domain for this question is this one. But after finding the domain, what we have to do, we have to convert this expression into the standard form. So in standard form, let me write it here, and here we can see that in the first term we have the deficiency of w, y and z. Okay, and the second term, which is yz prime, we have a deficiency of w, x. Okay, and in the third term we have w, z, we have a deficiency of x, y, and in the last term we have x, y prime, z, we have a deficiency of what? We have a deficiency of x here. Okay, so what we have to do here, we have this x prime. So in order to find the terms here, what we have to do, we have to multiply all the terms which are written here with w plus w complement, okay, y plus y complement, and the last one here is z plus z complement. Okay, similarly here we have yz prime, and with it I have to multiply w plus w complement, because this is the deficiency here, and x plus x complement. Okay, with this one what I have to do, I have to multiply wz, so I have to multiply x plus x complement and y plus y complement, and with this term, which is the x y prime, sorry, here we have the deficiency of the w here. Okay, w is not available here, so x y prime z, so I have to multiply w plus w prime. Okay, so what we will get here from here, let me first start solving it. So here I will get x prime w, okay, and the same terms will be multiplied with it. So here y plus y prime z plus z prime, and also here we have x prime w prime, and with it the multiplicative term will be what? Y plus y prime and also z plus z prime. Okay. Similarly, now simplifying it, I have been simplifying it here. So what I will get x prime w y, and here z plus z prime will be multiplied, and similarly x prime w y prime, and with it again z plus z prime. Okay. So now this term is, let me identify, these terms are done. Now let me solve these one. So here solving these one, what I will get x prime w prime y, okay, and z plus z prime, and also plus x prime w prime and y prime, and with it z plus z prime. Okay. Again solving them or simplifying them here, what I will get here, because now multiplying this term with all the terms here, this term with all the terms here, this with all the terms here, and this with all the terms here, what I will get x prime w y z plus x prime w y z prime, this is here, and now here x prime w y prime, okay, and z plus x prime w y prime and z prime, this one is here, and similarly now this one here plus x prime w prime y z, okay, and plus x prime w prime y z prime. Okay. Similarly the last one here x prime w y prime z plus x prime w y prime z prime. Okay. So these are all the terms which we have found by standardizing the first term, which is here, okay, which is here, and also multiplying all the terms here. What we will get the same terms, and after adding them and writing them, we will get that what are the terms which are basically zeros or ones here, and after finding all the terms, what we will have to do, we will have to draw the truth table. Okay. So this is the standard form of the SOP for this expression. After it, what we have to do, we have to find it by using this one. Okay. For WZ, we have to find it by using this one, and for the last one, we have to find it by using the expression which is given here, and then we will have to follow the same procedure which we have followed for our previous question in part A. Okay. So I think this part is also clear to you guys, and if you guys have any difficulty in learning or in finding the solution of it, please let me know in the comment section. So I hope it's enough for today, and I will see you with some more questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 36, and today we are going to talk about the part C of it. Okay. So in part C, we have 4 variables, and these are A, B, C, D. Okay. So therefore, let me choose the color, and the color is black. So the domain of it is, what? A, B, C, D. Okay. So after it, in order to find the sum of products here, SOPs here, what we will have to do, we have to identify all the terms for the ABCD for which the output is 1. Okay, so let me choose this blue for it, and the first term here is 1 and this one is also 1. You can see that the output for those two terms are 1 here. Similarly, this one, this, okay, this, okay. So these are 1 2 3 4 5 6 7 terms for which the output is what? Output is 1. So let me write them here. So these are 0 0 0 0 0 0 0 1, okay, 0 0 1 1, similarly 0 1 0 1, okay, so 0 1 1 0, and the term here is 1 0 0 1, and the last term is 1 1 0 0. Okay, so these are the terms for which we have to find the sum of products, and these are the terms for which we have to find the product of the domain variables, and it should give me the product of those terms should give me 1. Okay, so therefore what we will have to do, we have to complement it, complement and complement. So therefore what we will get here, so let me write it with this green color. So I will get A prime, B prime, C prime and D prime. Okay, similarly for the second term here, what we will have to do, we will have to complement the first three because these are the zeros, and when these will be complemented I will get 1. So all ones will be multiplied together and I will also get 1. So therefore A prime, B prime, C prime, D. Okay, this one here is A complement, B complement, C, D, because you can see that C and D are already ones while A and B are zeros. Here in this what we will have to do, we have to complement this A while B is already 1. Similarly C complement and the last term D. Okay, this term here, first and the last terms are 0, so therefore A prime, B, C, D prime, and this term first and last terms are 1 while all others are 0. So B prime, C prime and D, and the last term is A, B, which are 1s, and the last two terms which are 0. So I have to complement them as well. So these are complemented. Okay, so what we have to do in order to find the sum of products, what we will have to do, we have to sum them together. Okay, well, I have to sum all these products together. So what I will get, the output of it will be A prime, B prime, C prime, D prime plus A prime, B prime, C prime and D plus A prime, B prime, C, D. Okay, and here this one A prime, B, C prime, D. Okay, and plus A prime, B, C, D prime plus A, B prime, C prime, D, and the last term here is A, B, C prime, D prime. Okay, so what is this? This is the sum of product from my terms, and this is the solution for the sum of product what we have. Okay, so this is the answer of for part C. Here, in order to find the product of the sums, what we will have to do, we will have to identify all the terms for which the output is 0. So these are here, 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 all the remaining terms are zeros, and for it I have to write the sum for which the output should be what? 0, as we have done in our previous questions. Okay, so I think it's enough in which we have found the sum of product, and for part D you can also solve it for by using the same procedure which we have followed here. So I think it's enough, and if you have any question regarding the procedure which we have followed here, you can ask me in the comment box. Till then, take care of yourself, and I will see you in the next video. See you. Welcome back, guys. This is question 36. Okay, and here we have to find the sum of product and product of some expressions for all the terms which are in the form of these truth tables. Okay, so what we have to do, let me first find the product of sum and sum of product terms for the table A of my question. So let me write here the part A. Okay. So in part A, before finding the terms for the SOP, sum of product terms, what we have to do, let us identify all the terms which are 1 here. Okay, so first term is here, which is 1, second one is here, third one is here, and the fourth one is here. So these are all the terms which are what, which are ones. So and these are the domain for them are A, B, C. So what we have to do, I have to multiply each of the terms here such that I will get 1. Okay, so in order to get this 0 0 0 0 1 equal to 1, what I will have to do, I have to make this complement, and I have to make this 1. So therefore what I will have here for the first one, I will have A complement, B complement, and C. Okay, for the second term I have 1 0 0 1 0 0. Okay, so for it the first one is 1, while for the multiplication I have to make all the other two terms equal to 1. So therefore I will have to make the complement of it. So therefore I will have A, B complement, C complement. Okay, the third one is here, and that is 1 0 1. Okay, so in order to make it 1, I will have to make this B complement. So B complement C, and the last one is 1 1 1. This is already 1, so I will have it A, B, C. Okay, so in order to get the sum of product form, what I will have to do, I will have to add these terms together, and what I will get, let me write them with this blue color. Okay, so what I will get, A prime, B prime, C plus A, B prime, C prime plus A, B prime, C, and with it I will also have to add the last one as well. So let me add it here, A, B, C. Okay, so what is this? This is the sum of product form for my question, which I have to find here. Okay, in order to find the product of some expression, what I have to do, let me write the product of sum. Okay, so in order to find the product of sum, what I have to do, I have to identify the terms which are 0. So the 0 terms are this, 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 and this, because the output for them is 0. So let me write them here, and in writing them, what I will do, I will basically write them, I will have to write them A plus B plus C. Okay, so it will be here, and it will give me 0. Similarly, the second term here we have is this 0 1 0. So what I have to do, I have to make the summation of these equal to 0. Okay, so the second term here is 0 1 0. So in order to make it 0, what I will have to do, this is 0 0 0. So these are already 0. So the second term here we have is 0 1 0. So in order to make it 0, I will have to make this one 0 as well. So therefore the complement of A plus B complement plus C, it will be here. So the third term here is 0 1 1. Okay, and in order to make it 0, what I will have to do, I have to make these two terms complement. So A plus B complement plus C complement, here we will get it, and the last term is 1 1 0, that is 1 1 0, and here these two terms will be complemented, and I will get A complement plus B complement plus C. Okay, so after it, what I will have to do, as these are the max terms, so these are the sums. okay, and I have to multiply them because these are the product of the sum expression which we want. So therefore writing them here, let me write them with this blue color. So I will get a plus b plus c, okay, a plus b complement plus c, okay, a plus b complement plus c complement, and the last one is a complement plus b complement plus c, okay. So that is basically the max terms, okay. This is the expression for the min terms, this is for the max terms, and this is basically the answer for the product of sums, and these are the max terms. So that's it for the part A of our question, in which we have seen that how to find the sum of product or product of the sum expressions for the truth tables which we have, and in our upcoming video we will talk about the part B of our question. Till then, take care of yourself and I will see you soon. Welcome back, guys. So this is question 36, and again we have to find the sum of product and product of sum expressions for the terms which are given here, and that should be the standard sum of product and standard product of sum expressions, okay. So the part B of our question is here, and here in order to find the sum of product expressions, what we have to do, we have to indicate the terms for which the output is 1. So these are here, here and here, okay. So in order to find those terms here and writing the sum of products expressions, what are those terms? These are 101, 110, okay, and 111, okay. So in order to make the product out of this equal to 1, I have to complement it this one. So therefore I will get here a b prime c, okay. For it, what I have to do, I have to make this complement so that the product of these three will be equal to 1, okay. So therefore I will have the expression for it equal to a b c complement, and here as these are already equal to 1, so therefore I will have these ABC, okay. At the end I have to add them, and adding them I will get, let me use this blue color for it, and I will get AB complement C plus ABC complement plus ABC. So that is what, that is the sum of products expression for my truth table, which is in part B, okay. Similarly, for the product of sum expressions, what I will have to do, I have to find the terms for which the output is 0. So these are all these terms for which the output is 0. So let me write them here. So these terms are 0 0 0, 0 0 1, 0 1 0, and 0 1 1, and the last term is 1 0 0, okay. In order to find the product of sum out of them, I have to make the summation of these three equal to 0. So therefore this will be the 0 already, okay. For making the summation of these three equal to 0, I have to complement it. So therefore I will get a plus b plus c complement, and here this should be the complemented one. So I will get a plus b complement plus c. Here these two should be complemented. So a plus b complement plus c complement, and here this first one a should be complemented. So I will get here a complement plus b plus c, okay. So now let me multiply them together because these are the summations, and I have to find the product of the summations form. So therefore I have to multiply these products. So let me use this blue color for it, and I will get a plus b plus c, okay. The first term, the second term is a plus b plus c complement, the third term is a plus b complement plus c, the fourth one is a plus b complement plus c complement, okay. And the last one, let me multiply it here. A complement plus B plus C. So this is the last term, and this is what? This is the product of. So that's it for the part B of our question, and part C, part D will remain the same. And in order to find the product of sum, what I have to do, first of all, I will have to find out the terms for which the output is 1 for all the sum of product, and for the product of sum I have to find the terms for which the output is 0. Okay, I will solve them in our upcoming video. Till then, practice over all the stuff which we have covered till now, and I will see you with some more videos which will spread knowledge regarding the digital logic design and digital circuitry in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is section 4.8, and here we have in this section 3 questions, 37, 38 and 39. Okay, so in this series what we will do, we will solve each of the question in our upcoming videos and in this video as well. So here let me talk about the question 37, which is related to the Karnaugh maps. So what are basically the Karnaugh maps? Karnaugh maps are basically the maps for simplifying the Boolean expressions. Okay, and we will see that how these are used to simplify the Boolean expressions. So now here the question 37 is, draw a 3 variable Karnaugh map and label each cell according to its binary value. Okay, so what we have to do, we have to draw a Karnaugh map of the 3 variables. So let me call those 3 variables as A, B and C. Okay, so in the Karnaugh map what we will have to do, we will have to draw a table. Okay, just like it, this will be a table here. Okay, and here in this table we have to draw here, and here we have to write one variable, and let me write it with this color, and let me write it C. So here this C can have 2 values. Okay, what can be those values? Those values can be 0 and 1. Okay, similarly let me write here AB. So as these are the 2 variables here, so what are these? These can have also 4 values. So those values are 0 0 0 1. Okay, so after it what we will have to do in the Karnaugh map, I cannot write here 1 0 because 0 1 and 1 0 we will see that the difference between them will be of 2 bits, but the adjacent entry should have a difference of 1. So therefore I will have to write 1 1, and after it I can write 1 0. So you can see that there is a difference of only 1 bit in between them. So let me draw this table like it. Okay, so this is here, this is like this and this. Okay, so this is a table for the 3 variable Karnaugh map. So what else we will have to do? Let me now combine them. So now combining them, what I will get, let me use this blue color. So these 2 0 zeros will be here, and this 0 will be here. So this is 0 0 0, and similarly this 0 0 will also be here in this second first row second column, and this 1 will be here. So 0 0 0 1. Okay, similarly this will be here. So 0 1, and this 1 for which the column we have, this will be 0, and here I will have the same values in which row I am here. So that is 0 1, and the same value of the column, so that is 1 here as well. So 0 1 1. Okay, similarly now the row has been changed, so here it will be 1 1 and the column is 0 here. Okay, and this row again and the column here as well, and similarly the row here is 1 0 and the column is 0, and the row is 1 0 and the column is 1. Okay, so these are the entries for the Karnaugh map which I was going to draw here. So that is the Karnaugh map for the 3 variable, and all these values are the binary values for all the variables. Okay, so I think it's enough for today, and in our upcoming video we will try to talk about the problem 38 and 39. Till then, take care of yourself, and I will see you soon. Welcome back, guys. This is section 4.8, and today we are going to talk about the question 38 here, in which we have to draw a 4 variable Karnaugh map. Okay, so previously we have draw a Karnaugh map which was of 3 variables. So now we have to draw 4 variable Karnaugh map and label each cell according to its binary value. Okay, so in the 4 variable Karnaugh map, what we have, which variables can we have? So let me call those variables as A, B, C, D. Okay, so these are the variables which we are going to use here in the 4 variable Karnaugh map. So first of all, let me draw it. So this is the vertical, this is the horizontal axis. Okay, so this is it, and here let me separate them out. Okay, let me write here the first two variables, which are A and B, as these are 4 variables. So let me split them in the group of 2. So A, B and C, D. Okay, so these are the variables here, and let me draw them here as well. So writing their values, what we can do, so writing their values, these are A, B. So A, B can have 2 bits. So those 2 bits can have either 0, 0, 0, 1. Okay, after it I have to write 1, 1, and the reason of it I have mentioned in my previous video. So 1, 1 and also 1, 0. Okay, similarly I can also write them here for the CD as well. So 0, 0, 0, 1, 1, 1. Okay, and 1, 0. So this is what, these are the values of the variables which I am going to use here, and after it let me draw them here as well. So drawing it. Okay, and now these, and now these. Okay, this and this one as last one. Okay, so now writing their values here, what we can do, first of all taking these 2 variables, okay, and writing them here. So 0, 0, the row values, and then the column values. Okay, so this is the column here, so here 0, 0. Okay, now also this row is 0, 0 and the column here is 0, 1. Okay, row is 0, 0 and the column is 1, 1. Similarly, row is 0, 0 and the column is 1, 0. So this is the first row, and I have told you the method with which I have to write them here. Okay, now the row here is 0, 1 because it is now here 0, 1, and writing the column here, that is 0, 0. Okay, similarly row here is 0, 1 and the column here is 0, 1 as well. Similarly the row here is 0, 1 and the column is 1, 1, and row is 0, 1, column 1, 0. Okay, so this is for the second row. For the third row, the row is 1, 1, the column is 0, 0. This is, sorry, the row is 1, 1 and the column is 0, 1. Okay, the row is 1, 1, column is 1, 1 as well, and row is 1, 1, column is 1, 0. Similarly here, now the row is 1, 0, so 1, 0 and the column is 0, 0. Okay, this is 1, 0, this is 0, 1, 1, 0, 1, 1, 1, 0 and 1, 0. Okay, so what is this? These are basically the corresponding binary values for each of the cells, which I have also put them here, and I have shown you that how to write them, what is the method of writing the binary values which I have used here. Okay, so this is the solution for the question 38. I hope you have understood all the steps which I have solved here, and in the upcoming videos I will show you all the applications of the Karnaugh maps and how can we use them in order to simplify the Boolean expressions. So take care of yourself, and I will see you with some more interesting videos in our upcoming video. See you soon. Welcome back, guys. This is question 39, and here we have to write the standard product term. Okay, so this is the standard product term for each cell in a 3 variable Karnaugh map. Okay, so in question 37 we have solved and draw a Karnaugh map for the 3 variables. Now what do we have to do? We have to write the standard product forms for all the values which are mentioned here. Okay, so in order to do so, what we have to do, let me draw another map here. So let me draw another map for the 3 variables, because we are asked to find the values for the 3 variables. Okay, so here again we have, let me use the same color, that is C, and here we have AB. Okay, so what values can we have? These are also 0, 0, 0, 1, 1, 1 and 1, 0, and here I can have, okay, this is 0, 0, 0 1 1 1 and 1 0, and here I will have 0 and 1. Okay, so on the basis of these, what I will have to do, I have to write the corresponding standard terms for each of the values. Okay, so what do we have to do? I have to write the values such that the product of them will be 1. Okay, so in order to do so, here we have 0 0 0, so it means that all AB here, AB and C, these three are zeros, so here the product will be 0 as well if any one of the three is 0. So what do we have to do? We have to complement them all in order to get the product equal to 1 in the standard form. So what do we have to do? I have to write here A complement dot B complement dot C complement, so that all of these zeros will be complemented and I will get 1 and the product of them will be 1, because this is the condition for the standard product terms. Okay, in the second cell here I can see that the first two terms are here zeros, while the last one, which is C, is already 1. So what do we have to do? I have to complement the first two terms, so therefore the complemented terms will be A and B, and the last term will remain the same because this is already 1. Okay, here in this column I can see that this is the first column and second row. The first and the last entries are zeros, while the middle one is already 1. So therefore the first entry will be complemented, second entry will remain the same, while the third one will also be complemented. Okay, here in this the first is 0, so the first will be complemented while the other twos will remain the same. Here the last will be complemented, so A, B, C complement. Here we can see that all the terms here are ones, so therefore no entry will be complemented and therefore I will get A, B, C. Okay, here the last two entries will be complemented, so I will get A, B complement, C complement, and here the middle one is 0, so therefore A, B complement, C. Okay, so what is this? These are all the standard, these are all the standard product terms for a 3 variable Karnaugh map. Okay, so here we have found out the way of finding the variables for a 3 variable Karnaugh map, and I will show you that how to find the same for the 4 variable Karnaugh map as well. So here the procedure remains the same, as I have to find out the product which gives me the product equal to 1. Okay, so that's it for today, in which I have solved question 39 here. So this is the solution of the 39 question, and I will solve more questions in our upcoming video. Till then, take care of yourself and I will see you soon. Welcome back, guys. This is question 40. Okay, and today we are going to use a Karnaugh map to find the SOP for each expression. Okay, so what we have to do, we have to find the minimum SOP form for each of the expressions which are given here. Okay, by using the Karnaugh map. Okay, so let me try part A of this question. So in part A of this question, we have A prime, B prime, C prime plus A prime, B prime, C plus A, B prime, C. Okay, so we can very clearly see that we have three variables here which are A, B, C. So in order to draw the Karnaugh map for the 3 variables, what we have to do, we have previously seen that in order to draw it, we will have to draw this table like it is. Okay, so here we will have A, B, and here we will have C. Okay, so now after it, what we will have to do, in order to write the variables here, we will have here 0 0, 0 1, 1 1 and 1 0. These are the binary values for the AB, while here for the C we will have 0 and 1. Okay, so after it, what we will have to do, we will have to draw cells for each of the binary values here. Okay, and here we can see that this is A prime, B prime, C prime, so clearly these are the values. Let me write them here. writing the values here, we can see that this is 0 0 0. Okay, what is a prime, b prime, c? This is 0 0 1. Okay, and this is 1 0 1, because the complementary term is always 0, because the product should also always be 1. Okay, so in order to do so, what we will have to do, let me write the values here and putting ones where we get these values. So this is 0 0 0, so let me write 1 here. Okay, similarly this is the second one here is 0 0 1, so 0 0 1 is this one as well. Okay, this is 0 0 1, because these twos are zeros and this is 1. And I have also shown you guys in my previous video that how to draw the table for the 2 variable, 3 variables, 4 variables Karnaugh maps. Okay, similarly here we have 1 0 1, so 1 0 1 is here, so let me draw it here as well. Okay, all others will be zeros. Okay, so these are all the zeros here. Okay, what we will have to do now, we will have to combine the groups of them. So now we can very easily see that this is a first group of the 2 variables, in which we can see that AB is the A prime, B prime are the constant forms, because here we can see that the value of C has been changing while the value of AB has remained the same. Okay, so that is A prime, B prime, because both of them are zeros. Okay, similarly here in the other group, we can see that this one can be grouped together with this one as well. Okay, and we can see that here this is 0 0, this is 0 0, this is 1 0. Okay, so only B and C remains the same, while B is 0 here. So therefore I will have B prime C here. Okay, so these are the two values for the sum of the products, which will remain constant here. So therefore writing them here, what we will do here, the simplified term we will have will be A prime B prime plus B prime C. Okay, so what is this? This is basically the answer of my question, which is the simplified term, and we have simplified it by using the Karnaugh map. Okay, so this is the solution for part A of my question. Similarly, now solving part B of my question, we have here, this is part B. So for part B, we will have AC B prime plus C. Okay, so here we can see that this is not in the simplified term and neither in the standard form. So what we will have to do, first of all, I will have to simplify it and then convert it to the standard form. So therefore multiplying this term with all the terms inside of it, what we will get A B prime C plus A C dot C. Okay, so I will get here A B prime C, and here this C dot C will be C. Okay, so we can see that this is still not the standard form here. So therefore multiplying with it, the B plus B prime here. Okay, so what I will get A B prime C plus A B C plus A B prime C. Okay, I am also arranging it in my step, because these are the same questions which I have solved in my previous question as well. So therefore there shouldn't be any confusion in between them. Okay, so we can see that these are basically the two similar terms. So therefore writing them in a single step, what I will get A B prime C plus A B C. Okay, so these are the two terms for the standard sum of the product form. Okay, so in order to write them, what we will have to do, we can very easily see that these are the values which are 1 0 1, and for it I have 1 1 1. Okay, so now in order to draw the Karnaugh map for it, let me move down somehow. Okay, so now let me draw the Karnaugh map for it. Okay, so here I have A B and here I have C. Okay, and now values here are, this is 0, this is 1, this is 0 0 0 1 1 1 and 1 0. Okay, and cells here will be, this is first, second, third and fourth. Okay, now writing their values, what we can see that this is only 101 and 11. So 101 is 101 is here, okay, and 111 is here. Okay, these are the two terms. All the other terms will be zeros here. Okay, so now we can very easily see that there is only one group in which these two terms are constant here, and here we can see that this one is constant, which is the C, while there we have A. So therefore we have here AC. Okay, so the simplified term we have here is AC. Okay, so the answer of this question is AC. Okay, so this is the solution for part B of my question, in which I have simplified the SOP expression by using the Karnaugh maps. Okay, so I think it's enough for today, and I will see you with some more questions in our upcoming video. Till then, take care of yourself. Welcome back, guys. So we were solving the question 40 here, and today we are going to talk about the part C here. Okay, so the part C here is, we have A prime BC plus BC complement plus A BC plus BC complement. Okay, so we have here, in order to go further, what we have to do, multiplying it with all the terms inside this bracket and this one here as well. What I will get here, I will get A complement BC plus A complement BC complement. Okay, similarly here ABC, okay, and here AB C complement. Okay, so we have got these terms which are the SOP terms. So in order to find the binary values for them, what I will have to do, I will have to write here the binary term. So here this is the complementary term. For the first term here, the binary term I will have will be 0 1 1. For the second term here, I will have 1 1 0. Okay, for this term I will have 1 1 1, and for this term I will have 1 1 0. Okay, so these are the binary terms for my SOP terms which are in this expression. Okay, so what I will have to do, I will have to draw the Karnaugh map here as well. So this is the Karnaugh map. Okay, and here I have A, B, and here C. Okay, so after it, let me write the binary values for them. So this is 0 0 0 1 1 1 and 1 0, while for it I will have 0 and 1. Okay, so after it, let me draw all the cells here. Okay, so these are the cells, and now writing all the values for which I have here the 1. So this is 0 1 1. So for 0 1 1, the 1 will be here. Okay, the second one is 1 1 0. So 1 1 0 is here. Okay, the third one is 1 1 1. This one is here, and the fourth one is 1 1 0. Sorry, I have made a mistake here, and this was basically the A complement. Okay, so when this was the A complement, I would have here 0 1 1. Okay, so it was 0 1 0. So for 0 1 0, I will have here. Okay, so this is 1. So these are the actual binary value, because due to this mistake we have made a mistake here. Okay, so what are the groups here? We can see that here we have a group of 4 bits here, and this is here. Okay, we can very easily see that this is a group of 4, and all the other terms here are zeros. Okay, only we have a single group which is composed of these four, and we can very easily see that the only thing which remains here the same or constant is this b. So therefore we get this b. So therefore the simplified term here is for it is this b, and this is basically the simplified value for this question, and this is the answer. Okay, so for part b this is the answer. Now similarly solving part d, here we have all the terms which are mentioned here. So I have a complement, b complement, c complement plus a b complement, c complement plus a complement, b c complement plus a b c complement. Okay, so these are the values, and from it I can very easily deduct the binary values for them. So the first one will be 0 0 0, second one here will be 1 0 0, this will be 0 1 0. Okay, and for the last one I will have 1 1 0. Okay, so now for it let me draw the Karnaugh map for it. So Karnaugh map for the three variables again. Okay, so here I will have a b and here c. Okay, now also writing the values. So 0 0 0 1 1 1 and 1 0, and here I will have 0 and 1. Okay, so now drawing them, this and this here as well. Now writing these binary values for all the terms which are mentioned here. So writing 1 for the first one, so that is 0 0 0. For 1 0 0 I will have here. Okay, for 0 1 0 I will have here. Okay, and for 1 1 0 these terms will be here, while the other will remain 0. Okay, so therefore now taking these four terms, and we can see that these are making a group of 4, where the only constant term is this c. So this is the c complement which is constant here. So therefore the answer or the simplified value for this question is this c complement, and this is also the answer of my part D here. Okay, so we have seen that how to simplify the SOP expressions by using the Karnaugh map in this question, and I hope you have understood all the steps which we have followed here, and I will also solve some more questions related to this concept in our upcoming videos. Till then, take care of yourself. Welcome back guys, this is question 41. Okay, and in this question we also have to use the Karnaugh map to simplify each expression to a minimum SOP form. Okay, so the first question we have here is a complement, b complement, c complement plus a b complement c plus a complement b c plus a b c complement. Okay, so that is basically the question what we have. So first of all, what we will have to do, we have to find the binary values which are used in the Karnaugh map. Okay, so here the binary value will be 0 0 0. Okay, for this term the binary value will be 1 0 1. For this term it will be 0 1 1. Okay, and for this last term it will be 1 1 0. So these are the four terms which we will have to use. So now let me draw the Karnaugh map for it. Okay, so these are basically the three variables which are a, b and c. Okay, so now these are the three variables a, b here and c here. Okay, so after it what I will have to do, let me use this color for the number of bits. So this is 0 0, this is 0 1 1 1 and 1 0. Similarly here we have 0 and 1. Okay, now drawing all the cells as we have done previously. Okay, this and this. Okay, now putting values here, what I will do, by putting values here, what will happen here is that the first value is 0 0 0, so it will be here. Okay, this is 1, the other one is 1 0 1, so 1 0 1 is here. Okay, 0 1 1 0 1 1 is here. Okay, and 1 1 0 1 1 0 is here. All the other terms will be 0. Okay, so we can here very clearly see that it cannot be simplified because not any 2 or 4 or 8 of the bits which are ones can be combined together. So therefore it cannot be simplified. It is very clear here that this is a separate one, this is a separate one, this is separate, and this is separate one. This cannot be combined in the consecutive manners because these are very separate apart. So therefore we can say here is that it is the simplified one and no simplification is needed. Okay, so for this question no simplification is needed. Similarly, for part B of my question, here this is part B, and for part B let me write it here. So part B is AC, and here we have B complement plus B plus C complement. Okay, and here we have. So first of all, what we will have to do in order to find the minimum SOP form for this expression, first of all we have to simplify it, okay, and bring it to the standard form. So therefore multiplying this with all the terms here, what I will get here AC B complement plus B dot B plus B dot C complement. Okay, so here as this is B dot B, so it will be B. Okay, because X dot X is always X, so therefore now I will have AC B complement plus B, okay, plus B dot C complement. Okay, these are the terms which we have. So now multiplying these term with all the terms inside of it and opening it, what I will get, let me write the simplified one. So I will get here A B complement C plus A B C. I am also arranging it in the manner that which is feasible now, and also plus A B C dot C complement. Okay, we can very clearly see here that this is C dot C, and I know that X dot X prime is always equal to 0. Okay, so therefore making this term equal to 0. Okay, so this term will be 0. Okay, so now at the end what I will have A B complement C plus A B C. Okay, so these are the terms. Now writing the binary values for them, what I will have 1 0 1 here. Okay, and for here I will have 1 1 1. So these are the two binary values. Okay, now let me move down somehow. So now drawing the Karnaugh map for it, what I will have, this will be the Karnaugh map here. Okay, here we will have B A B and here C. Okay, and now writing the combination of the bits, I will have 0 0 0 1 1 1 and 1 0, and here 0 and 1. Okay, similarly now drawing all the cells here. Okay, these are the cells. Okay, so now writing these values, so 1 0 1 is here. Okay, and 1 1 1 is here. All the other terms are zeros. Okay, so these are the terms which are zeros. So now we can very clearly see that these are the two bits which can be combined together in a 2-bit form, and here also we can see that this one is constant here, also this one is also constant here. So the constant ones here are, this is A and this is C, so therefore the answer of it is AC. Okay, so therefore let me write it here. So the answer of it is AC, and this is the answer of this part. Okay, So this is AC and this is the answer of my question here. Now let me go upward as well and looking at the last part of this question, which is DEF prime plus D prime EF prime plus D prime E prime F. Okay, so let me write them here first. This is C, this is here DEF prime plus D prime EF prime plus D prime E prime and F prime. Okay, so this is basically the term. Now writing their binary values, because now the variables are D, E and F. So binary values here will be, the binary value here is 1 1 0. Okay, here 0 1 0 and here 0 0 0. Okay, so these are basically the binary values. And now drawing the Karnaugh map here. This is a Karnaugh map and the variables here we have are the DE and here we have F, and writing all the combinations here. Here it will be 0 0 0 1 1 1 and 1 0 and here 0 and 1. Okay, so here these are the combinations and drawing cells here. So these are the cells. Okay, so now after it, what we will have to do, let me write the values of 1 for the combinations which we have found here. So 1 1 0 is here, let me write 1 here, 0 1 0 is here, writing 1 here and here 1 as well. So these are all others as zeros. Okay, so now after it, we can see that this is a one combination of two ones where only any two of the bits can be constant. So here the 0 is constant and this another 0 is also constant. So here for this one we can write that the constant ones are D prime, because this is 0, and F prime. Okay, and similarly another combination what we have here is this one. Okay, and here we can see that this 0 is also constant, while here we have F constant. So therefore here we have E constant. So therefore E F prime. Okay, so therefore now these are the two simplified values which we have. So now writing the simplified version of it, what I will get D prime F prime plus E F prime, and that is basically the answer of the question part C. Okay, so that's it for today, in which we have solved the three parts of our questions. And we have seen that how to find the simplified version of any expression by using the Karnaugh map. I hope you understood all the steps, and I will see you with some more interesting questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. So this is question 42. Okay, and here we have to expand each expression to a standard SOP form. Okay, so here we have different parts, and we will try to solve all the parts to expand them to the standard SOP form. Okay, so let me start it with the part A. So part A, here we have AB plus AB prime C plus ABC. Okay, so here the domain of it is, let me write the domain of it first. So the domain of it is what? The domain of it is A, B, C. So therefore we can see that here we have a deficiency of C, while the other ones are completed. Okay, so in order to do so, what we will have to do, I will have to multiply with this term C plus C complement, because this is equal to 1 as we have previously shown you. Okay, so now writing it with this one, what I will get, AB C plus C complement. Okay, and here A B complement C plus ABC. Okay, so now multiplying it with all the terms which are inside, so what I will get here ABC plus ABC complement plus AB complement C plus ABC. Okay, here we can very clearly see that these are the two terms which are similar, and I know that ABC plus ABC, this is always equal to a single ABC term. So therefore, writing them in a single form, what I will get ABC plus ABC prime plus AB prime C. Okay, so what is this? This is basically the standard form of my expression, and here this is the answer what we wanted to find out. Okay, so that is the answer of part A here. Similarly, for part B of my question, what we have, this is part B, and writing it here, what I will get, so this is part B. Okay, and here we have A plus BC. Okay, here we can see that the domain of it is again A, B and C. Okay. And similarly, we can see that here we have a deficiency of B and C, and here is the deficiency of A. Okay, so therefore, what I have to do, I have to multiply with this first term. What I will have to multiply with it A, B plus B complement, okay, and C plus C complement, and with this what I will have to do, I will have to multiply with it A plus A complement. Okay, so now simplifying it, what I will get here AB, okay, and with it C plus C complement and plus AB complement C plus C complement. Similarly here, simplifying it and writing it, what I will get ABC plus A prime BC. Okay, so now also here what I will have ABC plus ABC complement. Similarly here AB complement C plus AB complement C complement plus ABC plus A complement BC. Okay, so after it, let me see that whether I have any terms which are duplicated. So this is the first term, and we can say that this is the duplicated term. Okay, here we have the duplicate term as well. Here ABC complement I have, and seeing any duplicate term, no, I don't have any duplicate term. Okay, so B complement C, I don't have any duplicate term here as well. Similarly here and here as well, I don't have any other duplicate terms. So therefore now writing them, what I will get ABC plus ABC complement plus AB complement C plus AB complement C complement plus A complement BC. Okay, so this is basically the standard term, and we can see that all the domain variables are available in each of the product term which are added together. Okay, so that is the answer of part B, and I think it's enough for this video as well, and I will try to solve part C in our upcoming video. Till then, take care of yourself. Welcome back, guys. So this is question 42, and previously we have seen that we have solved part A and part B of our question. Okay, and here we have seen the standard SOP forms for these parts. Okay, today we are going to solve the question 43 for part A and part B, and we have to see that how to minimize each expression here by using the Karnaugh map. Okay, so let me move down somehow. Okay, so this is our question here, and in part A here of 43, This is question 43 and this is part A. So what are the binary values which we can have here are basically 1 1 1 for this term, 1 1 0 for this term, and for this term I have 1 0 1. Okay, so after it, let me draw the Karnaugh map for it, as we have only 3 variables here. So drawing it for the 3 variables which are a, b, this is a, b, and here we have c. Okay, and after it, what we have to do here, I have to write the bits combination. So 0 1, okay, 1 1 and 1 0, and here 0 1. After it, let me draw the remaining cells here. These are the cells. Okay, and now writing all the terms one for which I have got these binary values. So let me write those values. So I have 1 for 1 1 1. So this is here, 1 1 0 is here, and 1 0 1 1 0 1 is here. Okay, all the other remaining terms are basically zeros. Okay, so these are basically the terms. So now in order to simplify them, we have to group all the ones with respect to their positions, which are 2s or 4s or 8s. So here we have the first combination of the 2s. Okay, so here these two can be combined together, and here we can see that the constant term here is the AB, because we can see that this A and B will remain same in this row. Okay, similarly we can see that here we can have another combination here as well of these twos, and here we can see that what are the constant terms. Here this one will remain constant. Okay, this one for A and this one for C. So I will have here AC. Okay, so therefore the simplified term for it, I will have what? So let me write it with this white color. So the simplified expression for it will be AB plus AC, and that is the simplified version for part A of our question. Okay, so that is the solution for part A. Similarly, for solving part B here, this is part B and this is question 43. Now what I have to do, I have to write the binary values. So binary values for these are 1 1 1. Okay, similarly 1 1 0, 1 0 1, 1 0 0. Okay, and for this last I will have 0 1 1. Okay, so after what I have to do, I have to draw the Karnaugh map here as well for the 3 variables. So this is a Karnaugh map. So after it, let me write the variables. So A, B and C here. Okay, and the bits combinations are 0 0, 0 1, 1 1, 1 0 and 0 1 here. Okay, after it, let me complete this Karnaugh map. Okay, so here this one. Okay, now writing once for all the binary values which I have got here. So 1 1 1 is here, 1 1 0 is here, 1 0 1 is, sorry, 1 0 1 is here, 1 0 0 is here. Okay, and 0 1 1 is here. Okay, all the remaining terms are now zeros. Okay, so here we can very clearly see that these 4 ones are combining together and giving me some constant value, and that is basically this A. Okay, so therefore the value for it is A. For these 4, the constant term or the constant value which is not changing is this A. Similarly, we can see that here we have also this combination here which is this column wise. Okay, and here we can see that this one for B is remaining constant, while this one for C, okay, is also constant. So therefore I can write here B C. Okay, so therefore I have these two terms, and writing them here, what I will get, let me write them here, and the simplified term here will be A plus B C. Okay, so that is basically the simplified version for this question. Okay, so that is the solution for the question 43 for part A and part B. We have solved it because previously we have seen the standard terms for these two parts, and we found it feasible to solve it first. So if you have any questions, you can ask me in the comment box. So I will see you with some more questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Hello guys, so this is question 42 and today we are going to solve part C of it, and after solving the part C for 42 we are also going to solve it for 43 as well. Okay, so the part C for the question 42 is here. So here we have A B prime C prime D plus AC D prime plus BC prime D plus A prime BC D prime. Okay, so these are the terms, and first of all I have to convert them to the standard SOP forms. So therefore I can see that here the domain I have is, domain variables are A, B, C and D. Okay, and here we can see that we have a deficiency of B, and here we have a deficiency of A. Okay, so therefore multiplying here some terms, okay, here I have to multiply B plus B complement, which is equal to 1, and similarly A plus A complement. Okay, so let me write them here, and I will get AB prime C prime D, okay, plus AC D prime, and with it I have to multiply B plus B complement to convert it to the standard term. Okay, similarly B C prime D, and with it I have to multiply A plus A complement. Okay, and the last term here is A complement B C D complement. Okay, so what are the steps here? I have to multiply this term with all the terms here and this with all the terms here, and simplifying them. The simplified terms here are the A B prime C prime D plus A B C D prime, okay, and A B prime C D prime. Okay, similarly now multiplying this term here I will get A B C prime D, okay, A B C prime D, and here we have A prime B C prime D, okay, and the last term here is A prime B C D prime. Okay, so let me look for all the duplicate terms. Here we have this first term, and is there any duplicate term for it? Let me see that. This is the first term, A B prime C prime. No, there is no duplicate term here. A B C D prime, A B C D prime, no duplicate term here. A B prime C D prime, A B prime, no duplicate term here. A B C prime D, no duplicate terms, and similarly all the terms here are unique here. So now to solve the question 43 here, what I have to do, let me write all the binary values for them. So these are the 4 variables, so let me write the binary values. So 1 0 0 1 for it, 1 1 1 0 for the second term, 1 0 1 0 for this term, 1 1 0 1 for it, 0 1 0 1 for it, and the last term here is 0 1 1 0. Okay, so these are the terms which we have seen here. So now let me draw the Karnaugh map here. So let me draw it here. Okay, as we have the 4 variables, so here I will have A B and here I will have C D. Okay, and writing the combinations here I will have 0 0 0 1 1 1 and 1 0, and here also 0 0 0 1 1 1 and 1 0. Okay, so now completing these cells, so completing these cells, what I will have, these are the cells. Okay, and then writing ones for all the binary values which we have got here. So 1001 is 1001 is here. So let me write 1 here. 1110 is 1110 is here. Okay, this term 1010 is 1010 is here. Okay, 1101 is 1101 is here. Okay, 0101 is here, 0101, and 0110 110, that is here. Okay, so these are the terms, writing all others equal to 0. Okay, so these all other terms are zeros. Okay, so after it, let me combine them in the form of the two variables. So therefore now here we have this 1 1, and the constant terms here are basically this b and what here, this cd. Okay, so b c d complement is here constant. Okay, similarly here what are the terms here? So again this cd prime is constant because this is the same column, and what is the constant term here? This is here a, so acd prime. Okay, similarly here we have this term. Okay, and here we have the constant term, this is 0 1, so c prime d, and here I also have this b constant, so bc prime d, and here okay what I will have here, again a is constant, so a, this is c prime d. Okay, so these are the terms, so let me write them here. The simplified terms are a c prime d plus b c prime d, okay, plus b c d prime plus a c d prime. Okay, so what is this? This is the simplified term which we have simplified by using the Karnaugh map here, and this is the solution for the part C in question 43. So that's it for today, in which we have solved these questions, and we have seen the solution of part C, and the part D is for your own practice. You can see that how to solve it and how to find the solution. So I will see you with some more interesting questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. This is question 45. Okay, and here the question is reduce the function specified in table 4.16. okay, this is table 4.6 4.16 to its minimum SOP form by using a Karnaugh map. So till now we have been using the Boolean expressions for simplifying the terms. Here we are given this table of the 3 variables. So the input variables are 3 and 1 output variable, and for it I have to simplify it. So this is basically more easier to simplify any function than we used to do by using the Boolean expression, because all the binary values are already given. Okay, so let me first draw the Karnaugh map here. Okay, so here we have this Karnaugh map. Okay, and the terms here are a, b, and here we have c. Okay, and what are the bit combinations? Here I have 0 0 0 1 1 1 and 1 0, and similarly here I have 0 1. Okay, so let me complete this Karnaugh map as well. So these are the cells. Okay, so these are basically the cells, and here I have to write ones for all the values where I have got this one. Okay, so I have this output equal to 1 for 0 0 0. So let me write here, let me use this blue color for it, or this black as well. So let me write here 1 for the 0 0 0, and for 0 0 1 as well. So this is also 1. Okay, similarly this 0 1 1 is also 1. So 0 1 1 is here. Okay, and also 1 0 0. So 1 0 0 is here. This is also 1. Here I have 1 0 1. This is also 1. Okay, and the last term here is 1 1. So this is here. Okay, so these are the terms which are zeros Okay, so now we have found this Karnaugh map. So in order to reduce the terms here, we can very easily see that these are the terms which can be combined in the form of what? 4 ones. So here the only constant term is this C. So here this constant is C. Similarly here this can be combined with this one because these are adjacent to each other, and any adjacent terms has the difference of 1 bits in between them. So therefore the only difference in between them is of this A. So BC remains the constant. So therefore for these terms we have B complement C complement. Okay, this is constant, this is constant, and also this is also constant. Okay, so therefore the output term or the simplified term for it is C plus B complement C complement. Okay, so that is basically the answer of our question, which we have simplified from this table 4.16 by using the Karnaugh maps. Okay, so that's it for today, in which we have solved this question from our book by using the Karnaugh maps. Okay, so that's it for today, and I will see you with some more interesting questions in our upcoming video. Welcome back, guys. So this is question 46, and here what do we have to do? We have to use the Karnaugh map method to implement the minimum SOP expression, okay, for the logic function specified in truth table 4.17. So this is the truth table 4.17, and we have to minimize this SOP expression from this truth table by using the Karnaugh maps. Okay, so what will be the first step? First of all, I will have to see that how many variables do I have. So domain of it contains 4 variables, and what are those? We have A, B, C and D. Okay, after it I have to draw the Karnaugh map. Okay, so this is basically the Karnaugh map what I have to draw. Okay, and this is what I have. This is A, B, this is C, D. Okay, and let me write all the combinations. So 0 0, 0 1, 1 1 and 1 0, and similarly for the CD as well. So 0 0, 0 1, 1 1 and 1 0 here as well. Okay, so let me draw all the cells. So this is the Karnaugh map. Okay, so this and this. Okay, so these are basically the cells for each of the binary combination which I have here in the form of the table 4.17. okay, what else I have to do? Here I have to look for all the values which are ones here and writing all the ones and zeros for all the combinations which I have here. So the first combination is 0 0 0 0, and for it I have here 0. So I will have to write here 0 just like it. Okay, so it will be 0. The second one is 0 0 0 1, it is 1. So this is 0 0 0 1 and it is 1, and so on. Okay, so let me first write all the ones here, and remaining ones will be the zeros. So using this method here, what will have? So this is 0 0 1 0. So 0 0 1 0 is here. So let me write here 1 as well. Okay, similarly here this one 0 1 1 0. So 0 1 1 0 is here. Okay, this one is 0 triple 1. So the 0 triple 1 is here. Okay, this one is 1 triple 0. So 1 triple 0 is here. Okay, this one is now 1 0 1 0. So 1 0 1 0 is here. 1 1 double 0 is 1 1 double 0 is here. Okay, this is 1 1 double 0, 1 1 0 1. So 1 1 0 1 is here, and the last item here is 4 ones. Okay, so 4 ones are here. All the other terms are zeros. Okay, So let me count that how many items do I have here which are ones. So 1 2 3 4 5 6 7 8 9. Okay, so 1 2 3 4 5 6 7 8 9. So these are the 9 terms. Okay, what I have to do, I have to combine them as I used to do in the previous questions in which I was using the Karnaugh map. Okay, so first combining these two ones, because these are making a group of twos, so this is a first group. Okay, similarly this is a second group in which these two are making a second group of ones. Okay, this one is the third group. Okay, this is a third group. Similarly this is a group in which this one is making a group with this one. Okay, and this last one is what, this is the alone one. Okay, so now writing the combinations for them. So here I can see that in this column 1 0 is common, so C D prime is common, and what else is common in between this and this bit? Okay, this and this bit. So this B is common in between them, so this is now 0, so I have to write B complement. Okay, so this is for these two. Similarly here I can see that in this row 0 1 is constant for AB, so I have to write A complement B. Okay, similarly I can see that this 1 1 is constant and not changing here, so this one is for here C, so I have to write here C as well. Okay, this is for this one. Similarly here for this one, what this is again 1 1 is not changing because this is the same row, so I have to write here AB. And what else is common here? This is another bit which is 1 here and not changing, and this is for D, so I have to write D here. Okay, so this is the D1. This item here, we can see that here the same column in which CD is not changing, so I have to write here C complement D complement, because the product of them should give me 1. Okay, so C complement D complement will give me 1. And similarly here you can see that this A is also not changing, so I have to write is this, because this is already 1, so I have to write here A C complement D complement. Okay, the last term here is this 1, because I can see that there is only one element here and it is not changing, so I have to write the binary combination for it, and it is here 0 0 0 1, so 0 0 0 1. So this is basically the term here. Okay, so now after it writing all the terms in the form of the sum of the product expression, which is the minimized one, so now writing them, what I have to do, first writing this one, so A C complement D complement plus now this one plus A complement B complement C complement and D. Okay, now this one plus B complement C D complement. Okay, now this one A complement D C. Okay, and the last one here is this one A B D, so A B D. So this is the last term, and this is what, this is the minimized sum of the product expression which we are asked to find out from this question. Okay, so this is the solution of our question, in which we have found out the values of the minimum SOP expression from the truth table which is given to us. Okay, so this is the solution of problem 46, and we have seen all the steps which are involved in this 4 variable Karnaugh map. Okay, so that's it for today, and I will see you with some more interesting questions in our upcoming video. Thank you so much. Welcome back, guys. This is section 4.10. Okay, and here we have to solve this question 48, in which I have to use a Karnaugh map to find the minimum product of sum for each of the expression. Okay, so here I am going to solve this part A. So in part A we have A plus B plus C. Okay, and A complement plus B complement plus C complement. Okay, and the last term here is A plus B complement plus C. Okay, so as we can very clearly see that these are all the product of sums. Okay, so these are the product of the sum form, and here we have the binary values which should give me the addition equal to 0. Okay, so therefore in order to give this addition equal to 0, the binary values for each of the sum term here will be what? That would be 0 0 0 for the first term. For the second term I should have 1 1 1, and for this term I should have 0 1 0, because this is a complete opposite of the sum of the product forms. Okay, and here the domain is also A B C. Okay, so this is the domain, and after finding the binary values, what I have to do, I have to draw the Karnaugh map. Okay, so let me draw the Karnaugh map here. So the Karnaugh map here will be for the 3 variables, because the domain is composed of these 3 variables. So A, B, and here I have C, and let me draw it here as well, and writing the combinations. So 0 0 0 1 1 1 and 1 0. Okay, similarly here I have 0 and 1, and drawing all the cells here. These are the cells here. Okay, after what I have to do, I have to write the ones for all the, I had to write ones for all the terms which were basically here in my SOP form. But here for the product of sum form, what I have to do, I have to write zeros for all the binary values. Okay, so here I have 0 0 0, so here this one is the entry here, this first entry, so here I have to write 0. Okay, so this is 0 0 0. Similarly I have 1 1 1, so 1 1 1 is here, and I have to write here 0, because this is a complete opposite of that of the sum of the product simplification which we have previously seen. And similarly 0 1 0, so 0 1 0 is here. Okay, so all the other terms will be ones. Okay, as we had previously seen in our sum of product simplification, that all the remaining terms were zeros, while all the binary values which we have found for the sum of products were composed of ones in the entries which were specified. Okay, so these are the zeros. Okay, so and in order to find the simplified or minimum POF, what I have to do, I have to gather the number of zeros in the form of 2s or 4s or 8s. Okay, so this is the first entry, and here I can very easily see that what are the constant terms. This is the first term which is constant, so that is A, because it will remain 0, so that is A, and with it this C will also remain 0, so I have to add with it this C. Okay, so this is A which are constant, and this is C, and as both of them are already 0, so I have to add them, and this is the first sum term. Okay, so similarly the second 0 is here, which is alone here, and these are 1 1 1, so therefore what I have to do, I have to make the addition equal to 0, so therefore I have to make all these 3 equal to 0. So A prime plus B prime plus C prime, this is the second entry. Okay, so here I have these 2 entries, and I have to multiply them together, and the output here I will have A plus C. This is the first term here which I have got here, and the second term is A complement plus B complement plus C complement. This is the second entry, and this is the simplified or minimum product of sum form which I have to find out. Okay, and this is what, this is the product of sum simplification. Okay, so here I had simplified it by using the what, by using the Karnaugh maps. Okay, so that is basically the solution of our question, in which we have seen all the steps which are required for the POS minimization. So I think all the steps are clear now, and I will see you with some more interesting questions in our upcoming video. Welcome back, guys. This is question 49, and again we have to use the Karnaugh map to simplify each expression to minimum product of some form. Okay, so previously we have seen the same question for the 3 variables. So now we have the 4 variables. So let me solve it first. Okay, and using the same procedure which we have previously seen. So here we have A plus B complement plus C plus D complement. Okay, so the domain variables are A, B, C, D. Similarly, here we have A complement plus B plus C complement plus D. Okay, and the last term here is A complement plus B complement plus C complement plus D complement. Okay, so the domain variables are already given, which are A, B, C, D, and after what I have to write the binary values. So the binary values which should fulfill each of the product term here equal to 0. Okay, so for it this A will remain 0 here, this is B complement, so it will be 1, this will be 0, and this complement term will also be 1. Okay, for the second term here, okay, what I will have here 1, for B I will have 0, for C I will have 1 because this is a complemented term, and this D will be 0 as well. And for the last term, all the terms are here complemented, so here I have to write these 4 ones. Okay, so these are the binary values, and after it we have to draw the Karnaugh map. So the Karnaugh map here will be, let me draw it. This is for the 4 variables, and here I will have A, B, and here C, D. Okay, after it let me write the binary combinations. So 0, 0, 0, 1, 1, 1, and 1, 0, and here 0, 0, 0, 1, 1, 1, and 1, 0. Okay, after it let me draw all the cells. Okay, these are the cells, and now writing the values of 0 for all the binary values which we have got. So this is the first value, this is now 0, 1, 0, 1, so 0, 1, 0, 1 is here, 0, 1, 0, 1 is here, so let me write 0 here. This is the first value. Similarly 1, 0, 1, 0, so 1, 0, 1, 0 is here, and all 4s are here. Okay, so these are the 3 values which we had here. All the other terms are 1s. Okay, so these are all the other terms which are 1s. Okay, and we can very clearly see that there is no way that these can be combined together in such a way that the adjacent terms are 1 bit away. So this is basically the first term which we have, this is the second term, this is the third term. Okay, and the same values we will have as we have here. Okay, so it means these cannot be simplified further, and this is the only answer which we have, so it cannot be simplified or minimized. But the concept here is to let you guys know that what are the methods of the simplifying the product of sum method. Okay, similarly here we can also find the sum of the product here as well if you want to find out. So and that way it will give me the first 4, this will give me the second 4 terms. Okay, these will give me the 4 terms here as well. Here I will have these 2's, here these 2's as well, and finding the simplified or minimized sum of product terms will be easier for us if we wanted to find out, but the simplified product of the sum forms cannot be found out from this expression which we have. Okay, so that's the solution of part A of our question 49, and I hope you have grasped all the concepts which are behind the Karnaugh map building for the 4 variables and writing the binary values for them. Okay, so I think it's enough for today, and I will see you with some more interesting questions in our upcoming video. Till then, take care of yourself, and I will see you soon. Welcome back, guys. This is question 50, and here we are given this table which we have used previously in our question, and here in this question we are asked to use this table 4.16 and determine the minimum P of S. Okay, POS means product of some expression using a Karnaugh map. Okay, so again we have to use the Karnaugh map here. So as we have here 3 variables, so let me first draw the Karnaugh map here for the 3 variables which are A, B, C. So A, B will be here and C here. Okay, and after it writing all the combinations. So 0, 0, 0, 1, 1, 1 and 1, 0, and here we have 0 and 1. Okay, so let me draw all the cells here. Okay, so these are the cells. Okay, so what do I have to do here? Here I have to write the zeros for all the values where the output is 0. Okay, so here we have 2 outputs in which I have got the 0. So these are the 2 outputs, okay, for which the for these are basically the 2 inputs for which the output is 0. Okay, so this is 0 1 0 and 1 1 0. So let me write the 0 for them. So 0 1 0 is here, so writing 0 for this combination, and similarly 1 1 0 is here and writing 0 for this as well 0. So writing all others as ones, so all others are ones here. Okay, so these are all, this is basically the Karnaugh map for us, and as we are here to find out the product of some expression, okay, and we are having this Karnaugh map. So what I have to do, I have to take zeros, okay, and simplify it from this Karnaugh map. Okay, so here I can see that these are the zeros, and to simplify the POS expression, what I have to do, I have to write the sums which should give me zeros. Okay, so here I can see that what are the terms which are constant here. So the first term which is constant here is this B. So as it is 1, so I have to complement it, so it will be complemented term. So B will be complemented because I have to make it 0. Okay, it is constant and I have to make it 0. And the second term which is constant, as this is the column for this 0, so 0 will remain constant here. So as it is already 0, so I have to write here C. Okay, so there are no other groups which can be combined together in the form of Z, in the form of 2s, 1s or 4s or 8s. So therefore this is the only term here, and therefore the answer here, or the minimum POS expression here is what? That is B complement plus C. Okay, so that is what, this is the minimum POS expression for our question which we had to find out. Okay, let me make it somehow clear. Okay, so this is the answer of my question 50, and we have seen that how to find the minimum product of some expression from the truth tables. Okay, so that's it for today, in which I have shown you all the steps which we have to perform in order to find the minimum POS expressions. So try these things by yourself as well, and I will see you with some other questions in our upcoming video. Take care of yourself, and I will see you soon. Welcome back guys, this is question 51 and here we have to determine the minimum POS expression for the function in table 4.17. okay, so here in the form of this truth table we are given some function and we have to find the minimum POS expression. okay, so let me write it here, the minimum product of sum expression. okay, so this is what, this is the topic of today's lecture. okay, so I have to find out it. okay, so what are the steps here? So the steps will remain the same. Here I have 4 variables. So first of all I have to draw the Karnaugh map for these 4 variables. So the Karnaugh map for the 4 variables, let me draw them here. okay, so this will be the Karnaugh map, and here I will have A, B, here C, D. okay, and writing all the combinations, bit combinations here. So 0 0 0 1 1 1 and 1 0 for AB, and for CD 0 0 0 1 1 1 and 1 0. okay, now drawing all the cells here, what I will have, so these are the cells. okay, so now these are all the cells. So now this is a Karnaugh map. What is the next step? Here I have to find out all the inputs for which the output is 0 and writing this 0 at those bit combinations. okay, so the first bit here is this 0 0 0 0. so here the output is 0, so let me write here 0 as well. So here this is 0. Similarly this input for which the output is also 0, so 0 0 1 1 is here. okay, I have to write 0 here as well. 0 1 0 0 is here as well. So 0 1 0 0 I have to write 0 here as well. 0 1 0 1 here, so 0 here as well. okay, this one here for which the output is 0, so 1 0 0 1, so 1 0 0 1 is here. okay, so this is 1 0 0 1. Similarly here this one 1 0 1 1, so 1 0 1 1 is here. okay, and the last one here is this one where 1 1 1 0 we have, so 1 1 1 0 is here. okay, all the other terms will be ones. okay, so this is the same table which we have seen in our previous question. okay, what I have to do here, I have to draw the Karnaugh map here by using the same procedure, but here as we have the product of the sum or POS, so what I have to do, I have to make groups of these zeros. so this is a first group. okay, and this is basically the second group what I have. okay, this is the third group. okay, this is a fourth group. We can see that this is one is the fourth group, and this cannot be combined with anyone, so this is the last one. okay, so first let me write the combinations for this one. so here I can see that the constant terms are here A and CD. so as these are all zeros, so what I have to do, I have to write A plus C plus D, so the sum of them is 0. okay, so this is now here. Similarly the other group is this, so let me write for them. We can see that this is the same row for it, so 0 1 will remain the same. so here I have to write A and complement B because this is 1 here. okay, so it is complemented, and the other term which is constant here is this C, so I have to write here C as well. okay, so A B complement plus C is here. Similarly the other term here is this one, so I can see that 1 0 is constant, so making A complemented and B writing the same one. And similarly this D is also constant. We can see that in moving from this column to here, this D is constant now, and which is 1, so therefore I have to complement it as well. So this one is here, and also here in between this and this I can see that this is the same row, and in this row the only constant terms, this is basically the same column, and here in this column we have C complement plus D complement because both of them are ones, and similarly the other constant term is this B, so this B is already 0, so therefore making it as well, writing it as it is. Similarly this 0 is alone, and there is no no 0 which can be grouped together with it to make it 2s or 4s of zeros. So therefore this writing the bit combination for it, I will have A complement plus B complement because this is the same row, and 1 0 for it for the CD, and C complement plus D. Okay, so this is basically the combination what we have. Okay, so these are all the product of sum forms. So these are all the sums, so writing them in the form of the product. So let me first write this one. What I will have here, I will have A plus B complement plus C. This is the first product. Okay, similarly now the second one is this A plus C plus D, so A plus C plus D. Okay, and after it what I have to write, the after it I have to write this one. This is A complement plus B plus D complement. Okay, and the next is here B plus C complement, B plus C complement plus D complement. Okay, and the last term here is, I can see that there are 5 terms, so 1 2 3 4 5. Okay, so the last term, let me write it here. So the last term is here, so A complement plus B complement plus C complement plus D. Okay, so these are basically the product of these summation terms. So therefore this is what, this is the product of sum form for the truth table which we have here, and this is the minimized or minimum form for the POS expression. Okay, so that's it for today, in which we have seen all the steps which are involved in finding the minimum POS expression for the 4 variable Karnaugh map. Okay, so I will see you with some more interesting questions in our upcoming video. If you have any question, you can ask me in the comment box. Take care of yourself.